Trace the universe's expansion back roughly 14 billion years, and you reach a hard mathematical boundary. Imagine watching a video of the universe playing in reverse. Galaxies pull closer together, stars dissolve into a blinding fog of raw heat. The distance between everything steadily shrinks. Keep reversing the footage, and eventually, all the matter and energy in existence is crushed down into a single point. This is the singularity. It is not an incredibly heavy object floating in a dark, empty room. It is the room itself compressed to zero size. We'll track how the universe evolved from a point with no dimensions into the massive architecture of galaxies, and finally into its inevitable thermal death. To grasp the origin of everything, we must first unlearn our basic understanding of nothingness. When you imagine nothing, you probably picture a dark, empty void. But an empty void still has physical properties. It has length, width, and depth. True physical nothingness lacks all of these. Before the singularity expanded, there was no space to hold anything. More importantly, there was no time. We usually think of time as a ticking clock running endlessly in the background. In reality, time is a physical structure woven directly into space. Think of time as the track that reality moves along. Without the track, motion is impossible. Physicists often compare the question of what happened before the universe to standing exactly at the North Pole and asking what lies further north. The physical direction of north simply stops existing at that exact geographic coordinate. In the exact same way, the concept of before means absolutely nothing without the dimension of time to measure it. The universe did not detonate outward like a chemical bomb into a pre-existing empty space. It had to create the fabric of distance from within. That leaves us with a severe paradox. If every particle of mass and energy was locked inside a state of zero dimensions, how did the initial stretching of space manage to outpace the speed of light without violating the fundamental laws of relativity? The absolute speed limit of reality is the speed of light. Yet in the fraction of a second after the singularity, the cosmos expanded exponentially, far exceeding that absolute limit. To resolve this mathematical contradiction, separate the act of moving through a room from the room itself expanding. Imagine two ink dots drawn on a flat rubber band. If a microscopic insect tries to walk from one dot to the other, its maximum running speed is strictly capped. It can only move so fast across the surface. But if a force grabs both ends of the rubber band and violently pulls them apart, the two dots recede from each other almost instantly. The ink is not traveling across the rubber. The rubber itself is generating new physical distance between the dots. Albert Einstein proved that no physical object, no mass, and no information can travel through space faster than light. However, space itself is not an object. Space is the underlying physical medium. Because the fabric of empty space has no mass, it is entirely exempt from the cosmic speed limit. This specific phase of existence is known as cosmic inflation. It lasted for a slice of time so brief that everyday measurements can't detect it. Exactly 10 to the power of -36 seconds after the absolute beginning, the universe ballooned in volume by a factor of 10 to the power of 26. A region of space significantly smaller than a single subatomic particle was violently stretched to macroscopic proportions in an unmeasurable fraction of an instant. This sudden, brutal stretching ironed out extreme quantum wrinkles in the fabric of reality, creating the flat, uniform geometry we observe across the sky today. But this runaway inflation was fundamentally unstable. When the rapid expansion suddenly halted, the sheer kinetic energy stored inside the stretching fabric had nowhere to escape. This massive braking force instantly converted the momentum of empty space into a boiling ocean of raw radiation. That triggered a chaotic threshold where the single master force of nature was about to fracture violently into four distinct competing mechanisms. Heat destroys structure. When you boil a block of ice, the rigid crystal matrix melts into fluid water and eventually boils into chaotic steam. Extreme temperatures erase boundaries. In the very first trillionth of a second after inflation halted, the universe was saturated with a temperature so high that the basic rules of physics melted into a single, indistinguishable master mechanism. Physicists call this the superforce. Today, 4 fundamental forces govern the universe we know. Gravity anchors you to the ground. Electromagnetism powers your nervous system. The strong nuclear force binds the core of every atom in your body, while the weak nuclear force dictates radioactive decay. But in the primordial furnace of the early cosmos, these 4 distinct pillars were fused. There was no difference between the pull of gravity and the spark of static electricity. As the rapidly expanding space began to cool, this perfect symmetry shattered. Think of a spinning coin on a smooth table. While it spins rapidly, it looks perfectly symmetrical, a blur of constant motion. But as it loses kinetic energy, it suddenly collapses and falls flat onto one distinct side. The early universe underwent a similar collapse. Gravity was the first to separate, pulling away to dictate the macro geometry of space. A fraction of an instant later, the strong nuclear force fractured off, claiming absolute dominance over the microscopic realm. Finally, electromagnetism and the weak nuclear force snapped apart. By the time the cosmos was 1/1000th of a second old, the 4 fundamental laws of nature were permanently locked into place. The architecture of reality was set. Yet this new rulebook could not immediately build stable matter. The ambient heat remained far too extreme for a single atom to survive. These newly forged forces were about to govern a blinding, opaque storm of raw plasma. It was a chaotic arena where the very first primitive particles were forced into a lethal war of annihilation against mirror copies of themselves. Heat is absolute motion. When a physical system is too hot, its internal components possess too much kinetic energy to bind together. Imagine trying to carefully stack delicate wooden blocks in the middle of a violent hurricane. The wind will strip the structure apart long before a second block is ever placed. For the first 380,000 years of its existence, the universe operated exactly like that hurricane. It was a chaotic, boiling soup of subatomic fragments known as a primordial plasma. Even though the 4 fundamental forces were now firmly established, they were entirely overwhelmed by the sheer ambient temperature. Gravity tried to pull mass together, and the newly separated electromagnetic force tried to fuse opposite charges. But the thermal energy was so intense that it tore every fragile atomic bond apart the instant it formed. During this prolonged era, the cosmos was physically opaque. Light itself, carried by fundamental particles called photons, was trapped inside the plasma. Every time a photon tried to travel in a straight line, it slammed into a free electron. It ricocheted off in a random direction. The entire universe was a blinding, infinite fog of trapped radiation and scattered energy. You could not see through it, but the expansion of space was unrelenting. As the universe's physical volume expanded rapidly, its overall temperature steadily fell toward absolute zero. The particles' frantic kinetic motion began to slow down. Eventually, the ambient heat dropped below a critical threshold. The electromagnetic force finally overpowered the thermal chaos. Protons and electrons paired as electromagnetism finally took over, creating the first stable hydrogen and helium atoms. Physicists refer to this exact mechanical shift as the era of recombination. By pulling the free chaotic electrons into stable atomic shells, the barrier that had scattered and trapped light instantly vanished across the cosmos. The blinding plasma fog lifted. For the first time in cosmic history, space became transparent. Photons surged forward in every conceivable direction, flooding the newly expanded void. That initial burst of trapped light did not simply fade away into the past. Its stretched and cooled remnants are physically washing over your skin at this exact second. Every telescope is a functional time machine because light takes time to travel across the cosmic void. Looking deeper into space physically means looking further backward into the history of the universe. In 1964, two radio astronomers named Arno Penzias and Robert Wilson were not actively searching for the origin of reality. They were working at Bell Labs in New Jersey, calibrating a massive horn-shaped antenna to detect faint radio signals from the outer edges of the Milky Way. But they encountered a severe mechanical frustration. A persistent low-frequency static continuously contaminated their data. It was not interference from nearby cities. It was not terrestrial military broadcasting. They even physically climbed inside the giant horn to manually scrub out accumulated pigeon droppings, assuming biological contamination was causing the anomaly. The static refused to vanish. Furthermore, it possessed a bizarre geometry. It was completely uniform, radiating evenly from every single coordinate in the open sky, regardless of where the antenna was pointed day or night. Without realizing it, Penzias and Wilson had accidentally tuned their instrument to the absolute edge of the observable universe. They were listening to the residual echo of the era of recombination. When the primordial plasma finally cleared, the cosmos was instantly flooded with a blinding white-hot flash of visible light. So why did this monumental flash register as a faint, cold microwave hiss on a radio antenna? This requires a fundamental shift in how we perceive the movement of energy. Light travels as a wave. Over the last 14 billion years, the physical fabric of space has been continuously stretching outward. As those ancient photons crossed the expanding void, the fabric of space stretched their wavelengths, lengthening visible light into much longer waves. The short, energetic wavelengths of primordial visible light were stretched into the infrared and then into the cold, low-energy microwaves we detect today. The blinding flash of creation had been stretched and cooled to just under 3 degrees above absolute zero. This phenomenon is the cosmic microwave background. It is the literal afterglow of the sudden expansion of space, permanently washing over the Earth. If you have ever watched an old analog television tuned to a dead channel, a small fraction of the scattered static dancing across the screen was the visual translation of this exact ancient radiation hitting the antenna. Modern satellites have since mapped this background radiation with extreme precision, revealing a nearly perfect uniform temperature across the entire sky. Yet this smooth perfection hides a severe structural paradox. Embedded within that microwave map exist microscopic temperature variations, deviations of only a few millionths of a degree. If the early universe was so incredibly smooth and uniform, how did these fragile microscopic thermal ripples manage to generate the immense gravitational force required to violently sculpt the colossal galaxy clusters we see today? Gravity is the relentless architect of the cosmos, but gravity requires a structural anchor to begin its work. Those microscopic temperature ripples mapped in the cosmic microwave background were not just thermal anomalies. They were the physical blueprints of reality. They marked specific coordinates where the density of primordial matter was infinitesimally higher than the surrounding void. In the mechanics of physics, mass attracts mass. For hundreds of millions of years following the release of the ancient light, the universe went completely black. The blinding flash of creation had stretched into invisible wavelengths. There were no stars to illuminate the expanding void. There were no planets. There was only a vast, freezing ocean of neutral hydrogen and helium gas drifting in absolute darkness. Astronomers call this era the cosmic dark ages. Think of a vast, tightly stretched sheet of fabric. If you place a heavy iron weight in the center, the fabric warps, creating a deep dip. If you scatter small glass marbles across the flat surface, they will slowly roll down into that central depression. The early universe operated on this exact principle. The microscopic density ripples acted as deep gravitational valleys. Over immense stretches of time, massive quantities of unseen matter began to pool into these valleys, constructing a colossal invisible web across the cosmos. The ordinary hydrogen gas was inevitably dragged along, falling deeply into these massive gravitational wells. It is a common human instinct to associate darkness with an empty void, a dead space where nothing happens. But astrophysics proves the exact opposite. The cosmic dark ages were not an era of emptiness. They represented a mandatory incubation phase. If the cosmos had remained a boiling, highly energetic plasma, gravity could never have successfully gathered material together. The ambient thermal energy would have constantly blown the fragile gas structures apart. The severe cold and absolute silence were fundamental mechanical requirements. The universe had to go dark before it could build the architecture of galaxies. Deep inside the cores of these gathering gas clouds, the structural pressure was mounting. Billions of tons of hydrogen were being crushed inward by their own cumulative weight. The intense internal friction spiked the core temperatures back into the millions of degrees. The long cosmic silence was about to be forcefully broken by an entirely new mechanical threshold, a localized ignition process capable of forging the solid heavy elements required to eventually build terrestrial worlds. In the 1920s, astronomer Cecilia Payne-Gaposchkin made a highly controversial discovery. By analyzing the sun's spectrum, she determined that stars are overwhelmingly made of hydrogen and helium. Modern stars, including our sun, also contain minor traces of heavier elements like carbon, oxygen, and iron. These heavy elements perform a critical mechanical function. They radiate heat and cool clouds. When a modern gas cloud collapses under gravity, these heavy elements emit radiation, actively cooling the cloud and allowing it to safely fragment into smaller, stable stars. But the early universe possessed zero heavy elements. The primordial gas clouds were structurally pristine, made of pure hydrogen and helium. Without heavy elements to dissipate the internal heat, these ancient gas clouds actively resisted collapsing. The thermal pressure pushing outward was immense. To overcome this resistance, gravity had to gather staggering quantities of material. The first generation of stars, classified by astrophysicists as population 3 stars, were forced to be massive. Our sun is a moderate, slowly burning sphere. These primordial structures routinely aggregated up to 300 times the mass of our sun. Their immense weight generated crushing physical pressure at their cores. The ambient heat spiked to tens of millions of degrees, forcing hydrogen protons to slam together and fuse. Nuclear fusion is the cosmos' dominant source of energy and light. A small fraction of the physical mass was instantly converted into pure radiant energy. The blinding light of these first stars tore through the surrounding hydrogen, officially ending the cosmic dark ages. However, their massive scale dictated their lifespan. Because they were so heavy, the gravitational crush on their cores was extreme. To prevent total collapse, they had to burn their pure hydrogen fuel at a furious, highly unsustainable rate. A moderate star like our sun burns steadily for roughly 10 billion years. These ancient giants exhausted their core fuel in just 2 or 3 million years, a microscopic fraction of cosmic time. They lived fast and shone with unmatched brilliance, but their extreme mass guaranteed a catastrophic conclusion. The outward radiation of nuclear fusion is the single physical mechanism preventing a star from instantly collapsing under its own colossal weight. What exactly happens to the local fabric of reality when a structure 300 times heavier than the sun abruptly exhausts its fuel, and gravity achieves absolute, unopposed control over that much mass? Gravity is infinitely patient. For a few million years, the blinding outward radiation of hydrogen fusion held the crushing weight of the primordial star at bay. But the moment the core exhausts its primary fuel, the fusion engine violently stalls. Gravity instantly seizes absolute control, forcing the entire massive structure to collapse inward. In the 1950s, physicist Fred Hoyle mathematically decoded this exact sequence, proving that stars are not just sources of ambient light, they are the active chemical foundries of reality. As the stellar core compresses under its own colossal weight, the internal temperature spikes to hundreds of millions of degrees. This extreme thermal pressure forces the leftover helium ash to ignite and fuse into carbon. When the helium runs out, the core collapses again. Temperatures climb, fusing carbon into neon, then oxygen, then silicon. The dying star organizes itself into distinct internal layers, structurally resembling an onion, with progressively heavier elements burning closer to the hyperheated center. But this cosmic manufacturing process has a rigid mathematical ceiling. Eventually, the extreme pressure at the center forces silicon atoms to fuse into iron. Iron is the absolute endpoint of stellar energy production. When a star fuses lighter elements, it releases radiation outward, which is the exact force holding the star up against its own gravity. But iron is fundamentally different. Fusing iron does not release energy. It actively absorbs it from the surrounding environment. The exact moment iron begins to form in the core, the outward thermal pressure falls away. The delicate mechanical balance that kept the star stable for millions of years is permanently destroyed. The star loses all structural support. Without any outward radiation to push back against the immense mass of the outer layers, billions of tons of superheated plasma begin to free fall directly toward the center. The iron core is instantly crushed to an impossible density. That sets the stage for a catastrophic mechanical rebound that violently rips the star apart and scatters its newly forged chemical inventory deep into the dark cosmos. Gravity's final victory over the star seems absolute, but physics demands a violent reaction. When the iron core collapses under its own immense weight, the crushing pressure forces protons and electrons to merge into a solid sphere of neutrons. The core shrinks from a diameter wider than the Earth to a dense sphere barely 10 miles across. It happens in a fraction of a second. At this extreme quantum density, the collapse abruptly halts. The core instantly becomes an immovable wall. Meanwhile, the billions of tons of outer stellar material are still in free fall. They rush inward at a significant fraction of the speed of light. This superheated plasma slams directly into the unyielding neutron core. The immense kinetic energy of this collision has nowhere to go but outward, triggering a devastating mechanical rebound. A kinetic shockwave of incomprehensible power blasts toward the surface. During the chaotic milliseconds of this shockwave, the physical environment reaches temperatures and pressures far exceeding the normal fusion engine of the star. Atoms are violently crammed together. This split-second detonation actively forges every element heavier than iron. The gold in our jewelry, the iodine in our biological systems, and the uranium now buried in the crust of the Earth are all forged during that split-second detonation. This mechanical event is a supernova. For a brief period, the detonation of a single dying star can outshine an entire galaxy. The sheer outward force physically tears the stellar structure apart, blasting its newly forged chemical inventory deep into the surrounding cosmic void. The universe was no longer a pristine, sterile expanse of pure hydrogen and helium. It was now enriched with the complex heavy elements required to eventually construct solid terrestrial worlds. Yet these newly scattered clouds of heavy dust and gas did not simply drift aimlessly through the vacuum. They were about to be caught in a much larger gravitational current. How did the underlying forces of the cosmos manage to sweep up these scattered remnants from countless detonating stars, overriding the chaos to construct the highly structured, rotating metropolises we recognize today as galaxies? In 1924, Edwin Hubble peered through the 100-inch Hooker telescope at the Mount Wilson Observatory and fundamentally shattered the boundaries of the known universe. Prior to his precise measurements, the scientific consensus assumed the Milky Way constituted the entire cosmos. Hubble mathematically proved that the faint glowing smudges drifting in the deep sky were actually entirely separate island universes. He had discovered galaxies, but the identification of these colossal structures immediately posed a severe mechanical question. How did the scattered chemical debris from ancient supernovas and the vast drifting clouds of primordial hydrogen organize themselves into such distinct massive architectures? The answer relies on a rigid law of physics known as the conservation of angular momentum. Imagine a massive shapeless cloud of gas slowly drifting through the vacuum. Because the universe is in constant motion, this cloud naturally possesses a slight, almost imperceptible rotation. As local gravity begins to pull the outer edges of the cloud inward toward its center of mass, the entire structure is forced to spin faster. This is the exact same mechanical principle that causes a spinning figure skater to accelerate when they pull their arms tightly against their body. As the immense cosmic cloud spins increasingly faster, the outward centrifugal force resists the inward pull of gravity along the equator of the spin. This dynamic tension physically flattens the spherical cloud into a vast, rotating disk. This specific sequence engineers the spiral galaxy, a flat, highly organized metropolis harboring hundreds of billions of actively forming stars. However, gravity ensures that isolation is temporary. When two large spiral galaxies inevitably intersect and merge, their orderly rotational disks are completely disrupted. The combined mass creates intense gravitational turbulence and violently scrambles the stars' orbital paths. Because the distance between individual stars is so vast, they rarely collide physically. Instead, their organized flat orbits are thrown into a random spherical swarm. This generates an elliptical galaxy, a massive, featureless sphere of older stars stripped of any organized spiral structure. When we observe the deep sky, these galactic systems appear isolated, drifting in an endless ocean of empty vacuum. Yet modern astronomical mapping proves they are not scattered by chance. If they formed independently from localized collapsing gas clouds, why do millions of distant galaxies perfectly align themselves into a highly structured, interconnected grid spanning the entire observable cosmos? Galaxies do not wander blindly. In 1989, astrophysicists Margaret Geller and John Huchra completed a three-dimensional map of a localized slice of the universe. Their precise data revealed an unexpectedly organized geometry. They discovered the Great Wall, a colossal sheet of galaxies stretching over 500 million light-years across the deep sky. This observation permanently shattered the assumption that galaxies float randomly in a uniform ocean of space. The cosmos is not a scattered soup of stars. It is a highly structured, interconnected grid. Astronomers call this architecture the cosmic web. Yet the sheer scale of this grid poses a deep gravitational puzzle. All the visible matter in the universe, every shining star, glowing nebula, and solid terrestrial planet, simply does not possess enough cumulative mass. It cannot exert the gravitational force required to build a structural web of this magnitude. The scaffolding holding the universe together is fundamentally invisible. Dark matter acts as the hidden skeleton of reality. Because it does not interact with electromagnetism, it cannot absorb, reflect, or emit light, making it entirely undetectable to optical telescopes. However, it possesses immense mass, allowing it to dictate the motion of ordinary matter. Dark matter forms dense, branching filaments that stretch across the vacuum like colossal cables. Ordinary galaxies are permanently anchored to these hidden cables. They are not drifting freely. Gravity drags them along dark matter filaments in steady, relentless currents. The galaxies flow continuously toward massive intersection points called nodes. At these specific cosmic crossroads, thousands of individual galaxies are violently compressed together to form towering superclusters. Cosmic voids are the vast regions bounded by these glowing filaments. These are vast, spherical regions of absolute desolation, frequently measuring hundreds of millions of light-years in diameter. If the Earth were located deep inside a standard cosmic void, the local night sky would be completely black, leaving early humanity entirely unaware that the rest of the universe even existed. The dark matter web elegantly organizes the macrostructure of the cosmos, but it also guarantees devastating local violence because the invisible filaments continuously funnel massive galactic structures towards shared intersection points. Severe spatial crowding is an absolute mathematical certainty. When the relentless pull of a gravitational highway drags two independent island universes into the exact same spatial coordinate, what happens to the billions of stars trapped inside when the local geometry of space physically collapses under the impact? In 1912, astronomer Vesto Slipher aimed a telescope at the Andromeda Nebula and recorded a severe mechanical anomaly. While almost every other object in the deep sky was racing away, driven by the expansion of space, Andromeda was aggressively shifting toward the blue end of the light spectrum. It was accelerating directly toward the Milky Way at 110 miles per second. Galactic collisions are a mathematical certainty of the cosmic web. The relentless pull of gravity operating along dark matter filaments ensures that local island universes will eventually intersect. In roughly 4 billion years, the Andromeda Galaxy and the Milky Way will suffer a direct head-on collision. Human intuition suggests this event will be a chaotic, apocalyptic catastrophe. Andromeda contains an estimated 1 trillion stars. The Milky Way holds hundreds of billions. When these two colossal structures slam together, it seems logical that millions of stars will violently smash into one another, shattering solar systems across the sky. Physics dictates a remarkably different reality. The sheer physical scale of empty space renders stellar collisions statistically impossible. Imagine a vast empty stadium representing a sector of a galaxy. A single star is the equivalent of a microscopic grain of sand hovering exactly in the center. The nearest neighboring star is another grain of sand located several miles away. When two galaxies merge, the two empty stadiums simply overlap. The structural geometry of the gas clouds and the dark matter halos is violently warped. The individual stars pass right through each other entirely unharmed. Instead of a kinetic demolition, a galactic merger is a gravitational reshaping. The massive tidal forces stretch the organized spiral arms of both galaxies into long chaotic ribbons of displaced gas. The dense hydrogen clouds from both systems collide and compress, triggering a furious burst of new star formation that will briefly illuminate the merging systems. Eventually, after millions of years of orbital turbulence, the two distinct spirals will settle into a single massive elliptical sphere. But while the billions of outer stars safely bypass one another, the absolute cores of the galaxies cannot avoid a far more severe fate. Lurking at the geometric center of both Andromeda and the Milky Way are objects of incomprehensible mass, each weighing millions of times more than our Sun. When the gravitational friction inevitably drags these two unseen anomalies together at the exact center of the new galaxy, what happens to the local fabric of space-time when two objects capable of permanently trapping light itself are forced to merge. Gravity possesses a strict mathematical breaking point. While serving in a muddy trench on the Russian front during the First World War, the German physicist Karl Schwarzschild calculated a profound mechanical extreme using the newly published field equations of Albert Einstein. Schwarzschild proved that if any physical mass were compressed tightly enough, its local gravitational pull would become absolute. He mailed these exact calculations to Einstein, unintentionally drafting the theoretical blueprint for a black hole just months before his own sudden death from an autoimmune disease. To understand this extreme, you must understand escape velocity. Every celestial body requires a specific outward speed to break free from its gravitational anchor. To successfully leave Earth, a physical rocket must accelerate to 25,000 miles per hour. If you were to mechanically crush the entire mass of the Earth down into a sphere the exact size of a glass marble, the gravitational density would violently spike. The required escape velocity would increase until it surpassed 186,000 miles per second. That is the absolute speed of light. Because no physical information in the universe can travel faster than light, nothing could ever leave that marble. This kind of collapse happens often in the deep cosmos. When a star at least 20 times heavier than our Sun detonates in a supernova, the surviving core might retain too much physical mass. If that leftover core weighs more than 3 times the mass of our Sun, the immense gravitational density utterly overwhelms the structural integrity of the crushed neutrons. Gravity secures a total, unopposed victory. The stellar core collapses inward on itself. It drags the surrounding fabric of space-time with brutal force. This local collapse creates the event horizon. It is not a solid physical surface that can be touched or landed on. It is a strict geometric boundary in the vacuum of space. It represents the exact mathematical coordinate where the inward flow of gravity officially exceeds the speed of light. Any physical matter or radiation that crosses this invisible threshold is permanently severed from the observable cosmos. Yet relativity dictates a bizarre optical paradox for anything approaching this dark boundary. To an outside observer, a massive object falling toward the horizon appears to decelerate smoothly, freezing in place and dimming to deep red. It never seems to cross the edge, but from the perspective of the falling object, there is no optical hesitation. It plunges directly through the threshold in a fraction of a second, pulled relentlessly toward the center of the darkness. What precise mechanical state waits for that crushed matter at the absolute geometric core, where the fundamental equations of physics simply cease to function? Crossing the event horizon does not instantly vaporize physical matter. If an observer were to fall into a supermassive black hole, the initial transit across the boundary would feel entirely unremarkable. But as they drifted deeper into the gravity well, the geometry of space-time would warp dramatically. This introduces a lethal mechanical gradient known as spaghettification. Gravity follows an inverse square law, so its strength rises sharply as distance decreases. As an object approaches the absolute center, the gravitational pull acting on its leading edge becomes hundreds of thousands of times stronger than the pull on its trailing edge. The spatial fabric itself stretches vertically while violently compressing horizontally. Any structured matter, down to the individual atomic bonds, is drawn out into an impossibly thin string of subatomic plasma long before it ever reaches the core. Yet the physical dismantling of matter is only a secondary symptom. The real oddity is a fundamental swap of space and time. In our normal universe, space is completely flexible. You can choose to move left, right, forward, or backward. Time, however, is rigidly locked. It flows strictly in a single direction, carrying you endlessly toward the future. Inside the event horizon, General relativity predicts that space and time exchange roles, undergoing a full structural swap. The inward gravitational flow becomes so severe that it physically overtakes the forward flow of time. Space becomes a rigid, inescapable funnel. Time becomes the radial axis pointing downward. This means the singularity at the core is no longer a physical location on a map. Because the dimensions have inverted, the singularity transforms into a fixed chronological coordinate. Just as you cannot turn around and physically walk back into yesterday in the normal universe, a particle inside a black hole cannot turn around and move away from the center. The singularity ceases to be a destination you fall toward. It becomes an inevitable moment in your future that you are mathematically forced to experience. Darkness constructs the brightest light. At the geometric core of almost every large galaxy sits a supermassive black hole, an object weighing millions or even billions of times the mass of our Sun. Human logic suggests these dense regions should be vast, invisible voids. Instead, they power the most luminous astronomical anomalies in the known universe. When colossal clouds of gas and shattered stellar debris are pulled toward a supermassive black hole, the material does not fall in a straight, clean line. The immense gravitational pull forces the matter to spiral inward, accelerating and flattening into a dense structure known as an accretion disk. Imagine a torrential volume of water swirling violently around a very narrow drain. As the cosmic material crowds closer to the event horizon, the intense physical friction between the compressed particles generates immense thermal energy, heating the disk to millions of degrees. This superheated plasma emits a staggering amount of radiation, creating a quasar. A single quasar can effortlessly outshine the combined light of trillions of normal stars, projecting a brilliant beam of energy across billions of light-years of empty space. Yet these cosmic titans harbor a fatal vulnerability. In 1974, theoretical physicist Stephen Hawking mathematically analyzed the precise boundary of the event horizon. He applied the rules of quantum mechanics to a threshold previously thought to be governed entirely by classical gravity. He discovered a profound mechanical leak. The vacuum of space is never truly empty. Microscopic pairs of particles and antiparticles constantly pop into existence, collide, and destroy each other in a fraction of a second. Hawking realized that if this spontaneous pair formation happens precisely on the edge of the event horizon, the extreme gravitational gradient physically separates them. One particle is pulled down into the black hole, while its partner is violently ejected into deep space. This escaping particle physically steals a microscopic fraction of energy from the black hole itself. Through this steady, relentless process, now universally recognized as Hawking radiation, black holes slowly evaporate. They are not permanent cosmic traps. Over time scales far beyond human comprehension, even the most massive black hole will completely bleed away into a faint, fading mist of residual radiation. Humanity has spent centuries building monuments of stone and steel, attempting to outlast the brief span of biological life by mimicking the presumed permanence of the heavens. We gaze at the night sky seeking eternal structures to anchor our understanding of time. Yet astrophysics proves that absolute permanence is a cosmic illusion. The slow, inevitable evaporation of a black hole confirms that extreme mass and gravity do not hold ultimate authority over existence. The total decay of the heaviest objects in reality proves that the true master of the universe is the underlying invisible fabric that holds them, a fabric that bends, ripples, and dictates the strict limits of motion. In the year 1905, a 26-year-old patent clerk named Albert Einstein upended the scientific view of space and time. Working in a quiet office in Bern, Switzerland, he lacked access to massive telescopes or advanced laboratories. Instead, he relied purely on rigorous mental simulations to prove that the speed of light is the absolute unbreakable constant of the physical universe. Human logic naturally assumes that velocity is additive. Imagine riding inside a high-speed train moving at 99% of the speed of light. If you walk forward down the aisle, basic arithmetic suggests your walking pace should be added to the momentum of the train, pushing you over the cosmic limit. Physics absolutely forbids this addition. The speed of light remains exactly 186,000 miles per second for every single observer, regardless of how fast they are moving or in what direction. Something else has to give to keep that rigid cosmic speed limit. Speed is defined as physical distance divided by time. Since the speed of light cannot change, distance and time must actively warp to accommodate motion. That produces the exact physical effect we call time dilation. As a mass accelerates towards the ultimate speed limit, its internal clock slows compared with a stationary observer. The actual passage of seconds is fundamentally stretched. The faster an object moves through space, the slower it moves through time. An astronaut traveling at extreme velocities will return to Earth measurably younger than the civilization they left, showing that time isn't a single universal tick, but a local variable tied to motion. Yet uniform motion alone is an incomplete picture. The presence of heavy matter warps time far more than velocity ever could. For nearly 300 years, the scientific consensus rested on a mechanical illusion. Isaac Newton described gravity as an invisible tether, an instantaneous pulling force across vast distances that held planets in their orbits. The model predicted the solar system's motion but failed to explain what actually caused it. Gravity does not actually pull. 10 years after dismantling the absolute nature of time, Albert Einstein published the theory of general relativity in 1915. He proposed that empty space and the chronological flow of time are not a passive background setting. They are permanently fused into a single dynamic physical fabric known as space-time. To grasp this cosmic architecture, visualize a heavy lead sphere resting in the exact center of a tightly woven trampoline. The immense weight of the sphere physically presses downward, stretching and warping the fabric into a deep spatial depression. If you roll a small glass marble across the outer edge of the trampoline, the marble does not travel in a straight, unaffected line. It begins to circle the central depression, guided entirely by the curved geometry of the fabric. The lead sphere is not magnetically pulling the marble. The marble is simply following the local curvature of its environment. The sun dictates the precise orbit of the Earth through this exact mechanical process. The Earth is continuously attempting to travel forward in a straight line, but the immense mass of the sun has severely warped the spatial fabric around it, permanently bending that straight path into a closed elliptical loop. This geometric distortion is so absolute that it controls the trajectory of light itself. When ancient photons from a distant galaxy pass near a colossal cluster of dark matter, their physical paths are deeply bent by the warped spatial geometry. This phenomenon, recognized as gravitational lensing, acts as a cosmic magnifying glass. It allows modern astronomers to visibly detect ancient galaxies hidden far behind massive foreground structures, proving that the vacuum of space is a moldable medium. Yet a warped trampoline only demonstrates a static environment. The universe is aggressively kinetic. When two incredibly dense structures, such as dead neutron stars, lock into a rapid orbital death spiral, their immense masses furiously drag the local fabric of space-time with them. This rapid orbital churning generates a violent mechanical friction, forcing the vacuum of space itself to physically vibrate and ripple outward across the cosmos. In 1916, Albert Einstein predicted a structural consequence of his own theory that he honestly believed humanity would never actually detect. He calculated that the sudden violent acceleration of massive objects would physically ripple the fabric of space-time, much like dropping a heavy stone into a perfectly calm pond. Yet his mathematical equations showed these spatial ripples would be so impossibly faint by the time they reached Earth that building an instrument sensitive enough to measure them seemed practically absurd. For exactly 100 years, the universe kept this mechanical secret completely hidden in the vacuum. Then, in 2015, the Laser Interferometer Gravitational Wave Observatory registered a microscopic spatial anomaly. Over 1 billion light-years away, two black holes had been locked in a rapidly decaying orbit. As they spiraled inward at extreme velocities, their immense masses violently churned the local vacuum, bleeding kinetic energy outward in the form of spatial waves. When the two dark spheres finally collided and merged into a single entity, the impact instantly converted 3 times the mass of our Sun into pure gravitational energy. This silent detonation sent a physical shockwave of warped space expanding across the cosmos at the exact speed of light. When that specific wave finally washed over the Earth 1 billion years later, it physically stretched and squeezed the entire planet. But the geometric distortion was infinitesimally small. The ultra-precise laser sensors measured a spatial expansion significantly smaller than the width of a single proton. By successfully detecting this microscopic stretching, astrophysics secured a brand new sense. Humanity no longer just looks at the light of the universe. We can physically listen to the structural vibrations of its most violent astronomical collisions. General relativity had achieved absolute predictive perfection on the macroscopic scale. It flawlessly dictates the mechanics of everything from drifting planets to merging island universes. But this flawless macrogeometry hides a fatal internal contradiction. The moment you shrink the mathematical lens down to observe the internal architecture of a single atom, the smooth, predictable curves of gravity instantly shatter into an erratic, chaotic realm where deterministic physics completely collapses. In the macroscopic universe, physical objects obey strict deterministic rules. A thrown stone follows a singular, predictable arc. But if you shrink that stone down to the size of a single electron, the mechanical certainty of its physical path completely evaporates. To comprehend the bizarre architecture of the microscopic world, physicists rely on the double-slit experiment. Imagine firing solid steel marbles through a barrier containing 2 narrow vertical slits. The marbles that successfully pass through will strike a back wall, eventually forming 2 distinct parallel lines. Now imagine sending a continuous wave of water through those exact same slits. The single wave splits in half, and as the 2 new waves overlap, they cancel each other out in certain places and amplify in others, creating a complex interference pattern of multiple scattered bands across the back wall. Solid matter creates 2 lines. Unbound waves create an interference pattern. When modern physicists fire individual solid electrons at this identical barrier one at a time, a profound mechanical anomaly occurs. Each electron physically strikes the back wall as a solid, localized dot. But as thousands of solitary electrons slowly accumulate on the detector, they do not form 2 parallel lines. They build the exact multi-banded interference pattern of a wave. A single, indivisible particle somehow travels through both slits simultaneously, physically interacting with itself in the empty space between the barrier and the wall. To resolve the paradox, scientists put a microscopic detector at the slits to record which path each electron actually follows. The instant the detector switches on, the interference pattern on the screen disappears. The electrons stop behaving as overlapping waves and instead act like discrete particles, forming just 2 distinct bands on the detector. The The mere physical act of gathering data permanently alters the structural nature of the particle. Before measurement, a subatomic particle has no definite position. It exists instead as a spreading cloud of overlapping probabilities. Only the mechanical act of observation forces that spreading cloud of probability to collapse into a localized solid state. Forcing a quantum particle to reveal its exact location comes with a precise mathematical cost. Isolating a physical coordinate scrambles and permanently corrupts any reliable calculation of its future momentum. In 1927, a 25-year-old German physicist named Werner Heisenberg was working through a severe mathematical crisis in Copenhagen. While attempting to map the exact orbital path of an electron, his equations repeatedly produced contradictory results. Heisenberg realized the failure was not in his arithmetic, but in the structural limits of nature itself. He formulated the uncertainty principle, proving that physical reality possesses a hard, mathematical resolution limit. To physically locate a subatomic particle, an observer must illuminate it by bouncing a photon of light off its surface. On a macroscopic scale, shining a heavy spotlight on a moving locomotive does not alter the momentum of the train. The kinetic impact of the light is entirely negligible, but in the microscopic realm, an electron possesses almost zero mass. When a single photon collides with an electron, it transfers enough momentum to kick the electron onto a new trajectory. The more narrowly you focus the wavelength of light to pin down a particle's position, the more kinetic energy you inject in the collision. That added energy then scrambles the particle's momentum. You can mathematically isolate where the particle is, or you can accurately calculate how fast it is moving. You are strictly forbidden by the fundamental laws of physics from knowing both simultaneously. This phenomenon is not a technological defect of human measuring instruments. It is an intrinsic property of the quantum fabric. Subatomic matter behaves as a spread-out wave of probability. That makes a sharp position and a definite trajectory mathematically incompatible states. The cosmos actively relies on this inherent quantum fuzziness. If the exact position and momentum of protons were rigidly locked, the extreme atomic compression required inside stellar cores would stall, and nuclear fusion would permanently cease. The stars burn simply because their atomic ingredients are mechanically uncertain. Yet this localized uncertainty generates a severe geometric violation when two distinct particles are mathematically forced to share the exact same wave of probability. Changing one particle's state instantly sets the mechanical state of its partner. This happens across billions of light years of empty space, with no physical signal passing through the vacuum. Distance is a geometric illusion. In 1935, Albert Einstein, alongside Boris Podolsky and Nathan Rosen, published a paper attempting to expose a fatal flaw in quantum mechanics. Einstein loathed the underlying concept of randomness. He famously declared that God does not play dice with the universe. But his rigorous calculations accidentally highlighted a quantum phenomenon so bizarre that he dismissed it outright as spooky action at a distance. Imagine flipping two separate coins. The physical outcome of the first coin has absolutely no mechanical influence on the second coin. Now, imagine a specialized quantum process that fires two electrons in opposite directions. These two subatomic particles are not independent, they are entangled. They mathematically share a single overlapping wave of probability. If one electron travels to a laboratory on Earth and the other travels to a laboratory on the Moon, they remain a unified geometric entity. Because of the uncertainty principle, neither electron possesses a definitive spin direction while in transit. They exist in a fluid state of multiple possibilities. But the instant a scientist on Earth physically measures the first electron, forcing it to collapse into a rigid state. For example, spinning upward, the electron on the moon will instantaneously collapse into the exact opposite state, spinning downward. The reaction occurs simultaneously. There is zero time delay. No physical signal travels through the vacuum of space between them. This instantaneous coordination appears to violently shatter the absolute cosmic speed limit of light. However, modern physics resolves this tension by recognizing that entanglement does not transmit usable data across the void. The two particles do not communicate. They simply behave as two coordinates of a single, undivided system. The microscopic realm operates on rules completely divorced from human intuition. Erwin Schrödinger, the physicist who officially coined the term entanglement, spent his later years deeply unsettled by the philosophical implications of his own mathematical equations. If the foundational building blocks of human biology and the surrounding environment are inherently uncertain and invisibly connected across infinite space, the rigid boundaries of physical isolation begin to dissolve. We are not separated observers standing inside a cold mechanical universe. We are macroscopic architectures constructed entirely from probability, intrinsically wired into the mathematical fabric of everything else. Yet this profound microscopic unity completely ignores the immense gravitational forces dictating the macro-universe. The flawless, smooth geometry of general relativity refuses to mathematically function alongside the erratic probability of the quantum realm, physically dividing the cosmos into two entirely incompatible realities. The visible universe is a physical lie. Everything human instruments can detect, every glowing star, dense planet, and bright nebula, is merely a minor contaminant floating in a much heavier, completely invisible ocean. In the 1970s, astronomer Vera Rubin was meticulously calculating the rotational velocities of stars located at the extreme outer edges of spiral galaxies. Based on the strict laws of a Newtonian gravity, she anticipated a precise mechanical deceleration. In our local solar system, a planet orbits slower the further it is from the mass of the Sun. Mercury races around the center, while Neptune drifts at a fraction of that speed. If Neptune suddenly accelerated to match the orbital velocity of Mercury, the central gravity would fail to anchor it, and the planet would be violently flung into deep space. Rubin observed that entire galaxies were aggressively violating this fundamental rule. The stars at the far outer rims of the galactic disks were spinning at the exact same extreme speeds as the stars packed near the dense core. The calculated mass of the visible luminous matter was mathematically insufficient to maintain the structural integrity of the spin. By all known laws of physics, the outer stars should have been forcefully shredded from their orbits and scattered across the void. Because the galaxies stayed intact, they must be wrapped inside an enormous, undetected scaffolding. Physicists call that hidden architecture dark matter. The term is misleading. The substance isn't dark at all, but completely transparent. It does not interact with the electromagnetic field. It cannot absorb, reflect, or emit a single photon of light. Yet it exerts immense gravitational authority. For every ounce of ordinary matter, there are roughly 5 ounces of this transparent substance shaping the universe's large-scale geometry. This massive invisible skeleton relentlessly pulls inward. It actively tries to crush the cosmos back together, but this colossal gravitational anchor is currently losing a mechanical war across the universe against the empty space between the galaxies themselves. Gravity was supposed to win. For most of the 20th century, scientists assumed a basic mechanical trajectory for the cosmos. If you throw a heavy stone upward, the gravitational pull of the Earth forces it to gradually decelerate. Physicists applied this exact logic to the expanding universe. The cumulative mass of hundreds of billions of galaxies, reinforced by the immense weight of dark matter, should have acted as a massive cosmic brake. It would have relentlessly pulled inward against the outward momentum generated by the initial singularity. In 1998, two independent teams of astronomers set out to physically measure this expected deceleration. They tracked distant Type 1a supernovas. Because these specific stellar detonations burn with a mathematically identical brightness, they serve as perfect cosmic milestones for measuring deep space distances. When the final observational data were processed, the results shattered the standard model of cosmology. The galaxies were not slowing down. They were aggressively accelerating away from each other. To account for this runaway outward momentum, physics had to concede the existence of a repulsive mechanism embedded directly into the vacuum itself. This phenomenon is classified as dark energy. It operates fundamentally differently from any known substance. Ordinary matter and dark matter naturally aggregate into dense, localized clumps, exerting a strict inward pull. Dark energy is an intrinsic property of empty space, exerting a uniform outward pressure across the entire cosmos. This establishes a devastating mechanical feedback loop. As the universe expands, it generates more empty space. More empty space inherently contains more dark energy, which physically pushes the isolated galaxies apart even faster. Dark energy currently accounts for roughly 68% of everything that exists, yet its exact quantum nature remains completely unidentified. This invisible spatial tension is actively overpowering the structural integrity of the dark matter web. By permanently dominating the gravitational struggle, this uniform outward pressure secures a specific, mathematically calculated endpoint, where the expanding geometry of space will eventually stretch so violently that the microscopic atomic bonds holding solid terrestrial planets together will be mechanically severed. The universe is fundamentally lopsided. Everything humanity has ever directly observed, every illuminated star, every biological organism, and every solid terrestrial planet constitutes a severe numerical illusion. When astrophysicists calculate the total mass and energy inventory of the cosmos, ordinary matter accounts for a mere 5% of the actual ledger. The remaining 95% is currently locked in a silent, invisible struggle for absolute structural dominance. On one side of this cosmic tug-of-war stands gravity, heavily fortified by dark matter. Comprising exactly 27% of the universe, dark matter operates as the ultimate architectural anchor. It relentlessly pulls the galactic filaments inward, actively attempting to compress the expanding void back into a dense, stable geometry. On the opposing side is dark energy, claiming a commanding 68% of the cosmic inventory. This repulsive tension is permanently baked into the vacuum of empty space. Gravity is a localized mechanical force. Its pulling power weakens exponentially as physical distances increase. Dark energy, however, is a uniform spatial pressure. As the universe expands, it mechanically generates more empty space. More empty space inherently contains more dark energy, which physically pushes the isolated island universes apart even faster. The war is mathematically decided. As the distances between superclusters grow, the inward grip of dark matter steadily decays, while the outward push of dark energy aggressively multiplies. The hidden structural skeleton of the cosmos is actively being stretched past its absolute breaking point. Humanity intuitively views the universe as a grand, peaceful theater, designed specifically to host stars and living planets. The physical truth requires a total shift in perspective. The cosmos is an active battlefield defined entirely by unseen kinetic tensions, where luminous matter is nothing more than glowing shrapnel caught in the crossfire. Yet mapping these colossal macroscopic forces completely ignores the most glaring mechanical failure in modern physics: the catastrophic mathematical breakdown that instantly occurs the moment scientists attempt to force the smooth, curving gravity of this expanding universe to interact with the chaotic, unpredictable quantum jitter of a single subatomic particle. Modern physics rests upon a catastrophic mathematical schism. Currently, human understanding relies on two heavily verified frameworks to decode reality. General relativity dictates the macroscopic universe, managing the smooth, continuous curvature of space-time that guides planets, stars, and colossal galaxies. Quantum mechanics governs the microscopic realm, defining a chaotic, pixelated world where subatomic particles act as fluid probabilities. Both theories are flawlessly accurate within their own specific spatial territories, but they violently reject one another. To observe this failure, visualize the absolute core of a black hole. Because a massive stellar core is crushed down into a state of zero volume, the local gravity is extreme, strictly requiring the equations of relativity. Simultaneously, because the physical arena is smaller than an atom, the erratic, probabilistic rules of quantum mechanics must also apply. When theoretical physicists attempt to combine these two mathematical systems to calculate the exact conditions inside that singularity, the equations immediately crash. The calculations output infinities. In astrophysics, generating an infinity is an undeniable signal that the underlying theory has completely failed to describe reality. This contradiction originates from the foundational geometry of each framework. General relativity requires space-time to be a perfectly smooth, uninterrupted surface. Gravity only functions because this geometric plane bends without breaking or tearing. Quantum mechanics demands the precise opposite. At the smallest conceivable scales of measurement, energy and spatial distance are not continuous. They are rigidly quantized, broken down into discrete, violently shifting packets. If an observer could magnify the quantum structure of empty space, it would not resemble a flat, flexible sheet. It would look like a violently boiling ocean of localized turbulence, rendering the smooth geometric curves of gravity physically impossible. The two dominant descriptions of the universe simply don't fit together. To break that mathematical deadlock and build a unified theory of quantum gravity, physicists must radically rethink matter's basic architecture. The foundational building blocks of the cosmos can no longer be modeled as zero-dimensional dots of solid mass. They must be reimagined as microscopic oscillating filaments. The resulting mechanical framework requires 7 extra undetected dimensions just to remain mathematically stable. To resolve the fatal mathematical collision between gravity and quantum mechanics, theoretical physicists proposed fundamentally redesigning the basic architecture of reality. For over a century, the standard model of particle physics assumed that the foundational ingredients of the cosmos, such as electrons and quarks, were zero-dimensional solid points of mass. String theory aggressively discards this assumption. Imagine the physical structure of a heavy piano wire. From a significant distance, the wire appears to be a simple, one-dimensional line. But if you magnify it closely, you can clearly see it possesses physical depth, thickness, and the capacity to vibrate. String theory says that if we could magnify an electron millions of times beyond our current limit, the solid point would disappear. In its place would be a microscopic, closed loop of pure kinetic energy. These loops do not exist as different physical materials. There is only one fundamental type of string. The physical properties of a particle are dictated entirely by how fast and in what specific geometric pattern the string vibrates. Like a heavy instrument string, a single quantum filament produces different results depending on how it vibrates. The same filament can appear to us as an electron, a photon, or the elusive graviton, the particle that would carry gravity. Replacing solid dots with flexible loops lets the math tame the sharp, chaotic jitters of the quantum realm. That smoothing finally makes it possible to connect quantum behavior to the curving geometry of general relativity. But this mathematical harmony demands a severe structural cost. When physicists attempt to calculate the complex vibrations of these kinetic loops within our standard human framework of 3 spatial dimensions and 1 dimension of time, the equations instantly fail. They produce mathematically impossible negative probabilities. To stabilize the internal vibrations, the strings strictly require more spatial directions to move through. Modern M-theory mathematically demands a universe constructed of exactly 11 dimensions. Human logic immediately searches for these missing 7 dimensions in the deep cosmic void. Physics dictates they are not far away. They are violently folded and curled tightly into microscopic geometric structures embedded directly into every single point of empty space. This mathematical architecture dictates a bizarre spatial reality. You're living inside an 11-dimensional framework and moving through those tiny curled geometries every time you take a step. Your biology limits your perception to just 3 spatial directions. That permanently blinds you to the complex physical machinery operating mere fractions of an inch from your own eyes. The physical boundary of our universe might simply be an illusion of dimension. In the late 1990s, theoretical physicists expanded the mathematics of string theory into a much broader geometric framework known as M-theory. They realized that microscopic vibrating strings are not the only physical structures allowed to exist within 11-dimensional space. The equations mathematically demand the existence of massive, multi-dimensional surfaces known as branes. To visualize this architecture, imagine a single, incredibly vast sheet of paper floating in a massive, empty room. The surface of the paper represents a 3-dimensional brane. M-theory suggests that everything humanity has ever observed, every spiral galaxy, every expanding nebula, and every speck of ordinary matter is permanently glued to the surface of one specific brane. We are structurally trapped flat against this cosmic paper, entirely unaware of the vast, higher dimensional space filling the room around us. But the mathematical models dictate that our sheet of paper is not alone. The higher dimensional bulk space is constantly filled with countless other parallel branes drifting completely independently. Some of these adjacent surfaces might be utterly devoid of physical matter, while others could possess radically different mathematical laws governing completely separate, unseen universes. While still a rigorous mathematical hypothesis rather than an observed fact, this framework provides a deeply elegant mechanical explanation for the genesis of our cosmos. Standard cosmology struggles to explain what triggered the Big Bang. Traditional equations catastrophically break down at the initial singularity. M-theory proposes a violent structural alternative known as the ekpyrotic model. The universe did not spontaneously explode outward from a microscopic dot of infinite density. It was the direct result of a massive kinetic collision, 2 colossal parallel branes drifting through the unseen higher dimensional space physically slammed together. The staggering kinetic friction of the multidimensional impact flooded our brain with energy. That energy produced blazing plasma and tiny density ripples that cooled and condensed into the galactic web we see today. This specific mathematical architecture completely overhauls the human perspective of cosmic time. It transforms into a repetitive, mechanical inevitability, guaranteeing that long after our current stars burn to ash and space expands into absolute freezing darkness, the invisible cosmic membranes will eventually drift back together and violently strike again. Time dictates an absolute mechanical end. Currently, the universe operates in a highly active period defined by the continuous ignition and burning of stars, but astrophysics confirms that the fundamental fuel required for this cosmic engine is strictly finite. The vast clouds of primordial hydrogen dispersed during the early expansion cannot last forever. Star formation is a highly inefficient mechanical recycling process. When a massive star detonates in a supernova, it scatters heavy elements and unburned gas back into the galactic environment. This debris eventually coalesces to forge the next generation of stars. However, a significant percentage of the original mass is permanently trapped inside the dead, crushed core of the star, locked away forever as a solid white dwarf, a dense neutron star, or an inescapable black hole. Every single time a new generation of stars is born, the cosmos permanently loses a massive fraction of its available structural fuel as the expansion of space aggressively continues. Driven by dark energy, the remaining gas clouds will be stretched far too thin for local gravity to successfully compress them. In roughly 100 trillion years, the machinery of star formation will permanently stall. The brightest and heaviest stars will be the first to vanish, having exhausted their core fuel in just a few million years. The medium stars, much like our Sun, will slowly swell and shed their outer layers before collapsing into cold, dim embers. The only surviving sources of light will be the red dwarfs. These tiny, incredibly efficient stars burn their hydrogen reserves at an almost imperceptible rate. But mathematics guarantees that even the most frugal red dwarf must eventually face terminal depletion when the final red dwarf exhausts its core and fades into a solid sphere of black carbon. The universe enters a profound phase transition. The long epoch of starlight will officially conclude. The cosmos will plunge into permanent freezing darkness. This marks the beginning of the degenerate era. The macroscopic galaxies will be completely unrecognizable. The majestic spiral arms and glowing hydrogen nebulas will be entirely gone. In their place will be vast, invisible swarms of dead stellar corpses drifting aimlessly through an expanding vacuum. The universe will be a cold, silent graveyard of white dwarfs, black holes, and rogue planets completely untethered from any central sun. Yet, this absolute darkness is not a static endpoint. The underlying architecture of physics dictates that even cold, dead matter cannot survive eternity. The protons that hold those dead worlds together have a finite, mathematically predicted lifetime, so the solid remnants will eventually dissolve into subatomic dust. Solidity is a temporary physical arrangement. Consider a fortress constructed from heavy block granite. Over millions of years, weather and erosion will wear the towering walls down, reducing the fortress to scattered dust. Yet the fundamental atomic structure of that dust remains perfectly intact. People naturally assume those basic building blocks of matter are immortal. Modern grand unified theories strongly challenge this assumption. In the 1970s, theoretical physicists tried to merge the strong, weak, and electromagnetic forces. They found a serious flaw in the standard model. The equation suggested that the proton, the heavy subatomic particle that physically anchors the nucleus of every atom in existence, might possess a hard mathematical expiration date over incomprehensibly vast stretches of cosmic time. The internal quantum bonds holding the proton together are predicted to spontaneously sever. The particle would abruptly decay, dissolving into a brief flash of radiation and lighter subatomic fragments. Mainstream science demands rigorous observational proof. For decades, physicists have maintained massive underground water tanks lined with ultra-sensitive light detectors, actively waiting to record a single proton decaying. To date, the sensors remain completely silent. This observational absence confirms that the proton is staggeringly stable, but it does not guarantee structural immortality. Current mathematical limits place the proton's minimum lifetime at a number of years so large it requires 34 zeros to write out. When applied to the extreme future of the cosmos, the physical consequences are absolute. If protons eventually decay, the frozen degenerate era will inevitably collapse. The trillions of dead white dwarfs, the dark rogue planets, and the crushed neutron stars silently drifting through the expanding void will not survive eternity. Over unyielding eons, the very atomic foundations of these solid corpses will quietly evaporate. The universe will systematically dismantle its own frozen debris, dissolving every remaining ounce of solid mass into a faint, expanding mist of elementary particles and fading photons. When the absolute final proton eventually decays, the cosmos will be permanently sterilized of ordinary matter. The dark geometry of space will be left only to the macroscopic structures mathematically capable of outlasting the death of atoms. An isolated network of supermassive black holes will sit in the freezing void, beginning their own agonizingly slow process of quantum evaporation. A closed thermodynamic system always moves toward absolute equilibrium. If you leave a heated iron sphere in a sealed vault, the thermal energy will steadily dissipate until the metal and the surrounding air reach the exact same temperature. Once equilibrium is mathematically achieved, all kinetic energy transfer permanently stops. The cosmos is strictly governed by this exact thermodynamic law. It is relentlessly marching toward a final state of maximum entropy, universally defined as the heat death. After the final protons dissolve into scattered radiation, the surviving architecture of reality will consist exclusively of isolated supermassive black holes, but these extreme gravitational wells are not permanent structures. Through the mechanical process of Hawking radiation, they will slowly leak their internal mass back into the expanding vacuum. This evaporation process is exceedingly gradual. For a supermassive black hole to completely dissipate requires a span of years represented by a 1 followed by 100 zeros. When the absolute final black hole eventually evaporates into a microscopic flash of residual radiation, the expanding universe will achieve total thermodynamic equilibrium. The ambient cosmic temperature will drop to absolute zero. There will be no light, no solid mass, and no available thermodynamic gradient to perform any physical work. Space will continue to expand indefinitely, stretching the remaining photons so thin that they become mathematically undetectable. The cosmos will not be structurally shattered, it will simply fade into eternal absolute stillness. Yet the permanent freezing of our specific timeline strictly assumes that our isolated geometric bubble is the entirety of existence. If the mathematics of multiple parallel branes hold true, our dark, expanding expanse is merely a single microscopic layer in a much larger multidimensional framework. The heat death of our local reality is not a definitive conclusion. It merely provides the necessary frictionless canvas for another wandering cosmic membrane to drift across the dark bulk space, guaranteeing that a massive kinetic collision will eventually strike the dead vacuum and flood the frozen geometry with blazing new energy. You are currently anchored to a single definitive version of reality. Every physical action you take feels absolute, permanently locking your past into a rigid, unchangeable timeline. But mathematics strongly suggests this singular existence is a massive cognitive illusion, actively hiding a continuous, violent fracturing of the cosmos. At the microscopic level, every time a quantum particle encounters a mechanical crossroads, reality does not simply choose one outcome. It physically shatters to accommodate every single mathematical possibility. In 1957, a 27-year-old physicist named Hugh Everett proposed a radical solution to the deepest contradiction in modern science. Standard quantum mechanics said a subatomic particle exists as a wave of overlapping probabilities until measurement. At that moment, the wave collapses into a single definite state. Everett realized that this sudden collapse violated the core deterministic equations of physics. He argued that the mathematical wave of probability never actually collapses. Instead, the universe itself aggressively divides. Everett introduced what is now recognized as the many worlds interpretation. Imagine a quantum particle that has exactly two possible paths to travel. Human intuition assumes the particle randomly selects one path, and the alternate possibility completely vanishes. The mathematics of Everett dictate a far more severe reality. The particle travels down both paths simultaneously. To mathematically accommodate this paradox, the entire physical universe instantaneously duplicates. The observer tracking the particle is part of the same quantum system. That means they are duplicated too. One version of the observer records the particle taking the left path. The newly created parallel observer watches it take the right. Both observers are entirely real. They possess the exact same biological memories and historical experiences up to the precise millisecond of the split. Once the timeline mathematically branches, the two resulting universes become permanently isolated from one another. They can never physically intersect, communicate, or share kinetic energy again. This is not a philosophical metaphor. It is a literal mechanical consequence of quantum equations attempting to process probability. Because everything in the macroscopic universe, including the dense structure of the human brain, is fundamentally constructed from microscopic quantum particles. These divisions scale upward infinitely. Human biology is simply not equipped to perceive this relentless duplication. You are standing on the fresh, microscopic debris of a trillion split realities. You are mechanically blind to the countless parallel versions of yourself who are simultaneously walking away from the exact choices you just made and living the thermodynamic consequences of the paths you mathematically abandoned. In 1935, Austrian physicist Erwin Schrödinger grew deeply frustrated with the prevailing mathematics of his own field. He engaged in a lengthy exchange of letters with Albert Einstein, both men lamenting the bizarre direction quantum mechanics was taking. Schrödinger designed a theoretical scenario to expose what he saw as a fatal logical flaw in the standard interpretation of subatomic physics. He meant it to be utterly absurd. He created the famous paradox of the cat. Imagine a perfectly sealed steel chamber. Inside sits a biological cat, accompanied by a microscopic fraction of radioactive material. The physical quantity is so precise that over the course of exactly 1 hour, there is an exact 50% probability that a single atom will decay, and an equal 50% probability that it will remain stable. If the atom decays, it triggers a Geiger counter, which mechanically shatters a small glass vial of lethal gas, terminating the cat. If the atom does not decay, the mechanism remains idle and the animal survives. The radioactive atom is a quantum object. The fundamental rules of physics dictate that before the atom is measured, it exists in a state of superposition. It is mathematically both decayed and intact simultaneously. But Schrödinger tethered a macroscopic biological organism directly to this microscopic uncertainty. If the atom occupies two contradictory states at once, the equations strictly demand that the cat must also exist in a blended physical state. Until a human observer physically opens the steel chamber to log the data, the animal is perfectly suspended between biological life and biological death. Schrödinger intended this scenario to sound entirely ridiculous. He was actively mocking the idea that the mere act of human observation could dictate the physical structure of reality. But the many worlds interpretation takes that absurdity literally, turning it into a straightforward physical process. Under the framework of Hugh Everett, the cat is never trapped in a ghostly overlapping state. At the exact fraction of a second, when atomic decay becomes mathematically possible, the universe cleanly bifurcates. The entire laboratory splits into two distinct physical geometries. In one universe, the atom decays, the vial shatters, and the observer opens the box to a dead animal. In the newly generated parallel universe, the atom holds together, the vial remains whole, and a duplicate observer finds the cat alive. Both timelines are entirely tangible, and neither observer possesses any mechanical awareness of the other. Humanity does not witness overlapping realities in daily life due to a strict environmental boundary known as quantum decoherence. A cat is not an isolated subatomic particle. It is a chaotic architecture of trillions of atoms constantly colliding with billions of ambient air molecules. This dense environmental friction acts as a relentless automatic measuring device. The delicate quantum superposition violently bleeds into the surrounding environment, forcing the local reality to lock into a single definitive state in a microscopic fraction of a nanosecond, yet recognizing the surrounding environment as the primary measuring device exposes a severe geometric paradox. The heavy steel box, the concrete laboratory walls, and the complex biological brain of the physicists standing outside are all fundamentally constructed from the exact same subatomic ingredients. There is no mathematical firewall separating the human observer from the quantum experiment. That means the physicist studying the chamber is fracturing into infinite parallel variations long before they'd reach forward to lift the lid. In 1964, an Irish physicist named John Stuart Bell was working at a prominent nuclear research facility in Switzerland. While analyzing the decades-long debate between Albert Einstein and the quantum pioneers, Bell recognized a profound philosophical deadlock. Einstein vehemently rejected the inherent randomness of subatomic physics. He mathematically insisted that particles must possess hidden variables, secret internal instruction manuals that predetermined their exact mechanical behavior long before any human instrument attempted to measure them. To permanently resolve this debate, Bell designed a brilliant mathematical trap. Imagine two automated machines producing identical pairs of sealed envelopes. If the factory operates on classical physics, every pair contains a pre-written identical list of answers. If you randomly select specific questions to ask the envelopes, the pre-programmed instructions guarantee a strict mathematical limit on how often the answers will perfectly match. This rigid ceiling is known as Bell's inequality. When modern laboratories finally acquired the precision technology to substitute the envelopes with entangled quantum photons, the physical data was undeniable. The photons matched significantly more often than the pre-written instruction manuals mathematically allowed. The physical consequences of this measurement are absolute. There are no hidden variables. The cosmos does not possess a secret underlying deterministic code. At the deepest microscopic level, reality operates on genuine, unadulterated probability. When a quantum particle faces a mechanical crossroad, the outcome remains unwritten until the exact fraction of a second when the interaction occurs. This randomness provides the mechanical foundation for the many worlds interpretation. A quantum system has no predetermined instruction and is governed by probability, so the equations of physics cannot discard the unchosen mathematical outcomes. To maintain thermodynamic balance, the vacuum of space accommodates the unused probability. It does so by instantly forming a separate, parallel region that contains the alternative physical outcome. Generating a new parallel reality requires an immense, explosive expansion of spatial volume. That idea discards the slow evolution of standard cosmology and forces scientists to examine the briefest, most violent fraction of a second, when empty space stretched faster than the speed of light. The background temperature of the deep cosmic void is unnervingly uniform. If a modern astronomer points a microwave telescope at the observable universe's extreme northern edge and then pivots to the extreme southern edge, the residual heat from the Big Bang reads identically cold. The temperatures match perfectly, down to a microscopic fraction of a degree. Classical physics cannot explain that thermal uniformity. Imagine dropping a heated stone into the freezing ocean and watching the water temperature across the entire planet equalize instantly. The opposing edges of the visible universe are separated by roughly 93 billion light-years of empty vacuum. They never had the time to exchange heat or communicate in any way. Yet they are flawlessly synchronized. In 1979, American theoretical physicist Alan Guth realized the only way to resolve this thermodynamic paradox was to rewrite the universe's earliest timeline. He developed the mathematical framework of cosmic inflation. Guth proposed that during the first infinitesimal fraction of a second after the initial genesis, the universe did not expand at a gradual, steady pace. Instead, a unique state of extreme quantum pressure caused the actual geometry of empty space to violently hyper-expand. Over a period significantly shorter than a single trillionth of a second, the spatial volume of the cosmos doubled repeatedly, stretching outward exponentially faster than the absolute speed of light. The cosmic speed limit strictly prohibits physical matter from accelerating past 186,000 miles per second, but there is absolutely no mathematical restriction on how fast the blank fabric of empty space itself can physically stretch. This hyper-expansion cleanly solves the thermal paradox. The entire observable cosmos was once a microscopic, intimately connected dot of energy, where the internal temperature had ample time to thoroughly equalize. Inflation then aggressively stretched that perfectly balanced dot to a macroscopic scale before the thermal harmony could be disrupted. Everything humanity currently observes is simply a highly magnified fragment of that original synchronized quantum dot. The mathematical equations of inflation flawlessly stabilized the standard model of our local universe. However, when theoretical physicists scrutinized the specific high-energy quantum field necessary to drive this sudden spatial acceleration, they uncovered a structural anomaly. The mathematical fuel required to inflate empty space completely refuses to naturally switch off, guaranteeing that the violent, explosive genesis of our reality was not a singular historical event, but merely an ongoing mechanical function. The expansion of space was never designed to stop. Human logic assumes the Big Bang was a single definitive explosion that birthed the entire cosmos. Modern mathematical models completely shatter this assumption. In 1983, theoretical physicists Alexander Vilenkin and Andrei Linde independently analyzed the quantum mechanics driving cosmic inflation. They discovered a severe mathematical flaw in the idea of a universal shutdown. The extreme energy field responsible for hyper-expanding the void is intrinsically subject to random quantum fluctuations. It simply cannot cool down and shut off everywhere simultaneously. Imagine a massive pot of actively boiling water. The turbulent rolling liquid represents the rapidly expanding, high-energy vacuum of space. Within this chaotic fluid, localized regions randomly drop in internal pressure, forcing the liquid to violently transition into microscopic bubbles of steam. In astrophysics, this mechanical transition is categorized as eternal inflation. As the primordial energy field randomly collapses in localized pockets, the rapid spatial inflation in that specific geographic area suddenly halts. The immense kinetic energy trapped in the vacuum instantly dumps into the newly formed pocket, converting directly into blazing radiation and dense matter. This localized kinetic dump is exactly what humanity perceives as the Big Bang. Our entire observable universe, containing hundreds of billions of spiral galaxies, is completely encapsulated within one of these isolated quantum bubbles. But outside the rigid boundaries of our specific bubble, the high-energy vacuum continues to relentlessly expand at speeds far exceeding light. Because the surrounding space physically stretches exponentially faster than the individual bubbles can organically grow, the separate universes are permanently driven apart. They can almost never physically touch or exchange thermal data. The cosmos is not a singular expanding balloon. It is an infinitely growing, violent ocean, constantly generating an endless cascade of entirely new, parallel bubble universes. This endless boiling architecture successfully explains the absolute vastness of reality, but it accidentally triggers a deeply uncomfortable biological paradox. If the quantum collapse that forged our specific bubble was dictated completely by random kinetic chance, why do the strict mechanical laws governing this exact pocket of space perfectly calculate out to support complex cellular life, while the mathematics strongly suggest the overwhelming majority of surrounding bubbles should be entirely sterile? The physical architecture of reality appears deliberately rigged. If a theoretical physicist could somehow access the foundational control panel of the cosmos and slightly adjust the mechanical dials of the universe, everything would instantly collapse into a sterile void. The standard model of physics is strictly governed by a specific set of fundamental constants. These include the precise mass of an electron, the exact strength of gravity, and the specific tension of the strong nuclear force holding atomic cores together. These numbers are not mathematically derived from a master equation. They are simply raw, observed data points that happen to be perfectly balanced. Consider the immediate kinetic consequence of altering just one of these dials. If you increase the strength of the electromagnetic field by a mere 4%, the internal fusion engines of every star in existence would violently stall. The cosmos would plunge into absolute darkness, completely incapable of forging the heavy carbon required to build cellular biology. Conversely, if you decrease the strength of gravity by a microscopic fraction, the primordial gas clouds expelled by the Big Bang would never possess the necessary structural weight to compress and ignite. The universe would remain a rapidly expanding, freezing fog of isolated hydrogen atoms. For decades, this extreme, razor-thin precision forced science into a difficult philosophical corner. It strongly hinted at deliberate conscious design. But the concept of eternal inflation provides a starkly mechanistic alternative. If the actively boiling quantum ocean is continuously generating an infinite cascade of parallel bubble universes, the fundamental physical constants are not deliberately tuned, they are simply randomized. The overwhelming majority of the surrounding multiverse is undeniably a pitch-black, hostile wasteland. Trillions of parallel bubbles likely possess blindly shuffled mechanics that cause them to immediately crush themselves back into microscopic singularities, or expand so aggressively that their internal subatomic particles are instantly shredded apart. Humanity exists only in this specific, highly improbable bubble, because biological observers cannot evolve in the sterile dead zones to notice their absence. We are not the favored occupants of a perfectly designed cosmos. We are simply the biological consequence of a blind, infinite cosmic lottery. Yet randomly shuffling the fundamental laws of physics across trillions of universes requires an underlying mechanism. That mechanism must be capable of actively altering the internal properties of empty space. To understand exactly how the vacuum can forge an endless variety of realities, astrophysics must drag the macroscopic geometry of the expanding multiverse back into the microscopic machinery of string theory. That machinery operates in 11 dimensions. The visible laws of physics are strictly geographic. In the earlier analysis of microscopic string theory, the mathematical models strictly required the universe to operate within an 11-dimensional framework. Because human biology perceives only 3 spatial directions, the remaining 7 spatial dimensions are compressed and curled up into microscopic geometric structures. They are permanently hidden within every single point of empty space. To grasp this unseen architecture, imagine folding a flat piece of heavy paper into an intricate shape. The specific way the physical material is folded directly dictates how it will mechanically interact with the surrounding air resistance when dropped. In the quantum realm, the precise geometric folding of these hidden spatial dimensions directly dictates exactly how the fundamental strings of energy are allowed to vibrate. If you physically alter the microscopic folding pattern of the hidden space, you instantaneously change the kinetic vibration of the embedded string. By altering that vibration, you completely rewrite the physical properties of the resulting subatomic particle. A brand new geometric fold could instantly convert a heavy structural proton into a fast-moving photon, or drastically multiply the sheer pulling strength of gravity. When theoretical physicists attempted to calculate exactly how many different ways these 7 microscopic dimensions could fold, the resulting number completely shattered classical comprehension. The rigorous equations allow for roughly a 1 followed by 500 zeros of distinct stable geometric combinations. This incomprehensible mathematical landscape provides the exact mechanical engine required to physically fuel the eternal inflation of the multiverse. The rapidly boiling quantum ocean expands and randomly collapses to forge endless new bubble universes. The microscopic dimensions inside each newly isolated bubble fold randomly into one of those 10 to the power of 500 possible shapes. This vast theoretical terrain is classified as the string theory landscape. It mechanically guarantees that practically every single newly born universe will operate under a completely alien set of physical laws. Most bubbles will instantly crush themselves back into microscopic singularities, while others will violently tear their own atomic structures apart in a matter of seconds. But with an absolutely infinite supply of aggressively expanding space, the cosmos simply brute forces its way into generating stable biological reality through sheer mathematical volume. Yet if the absolute existence of complex human biology is nothing more than a statistical inevitability dictated by a massive, blind cosmic lottery, modern science must directly confront a profoundly uncomfortable philosophical boundary where rigorous physics begins to dangerously resemble unquestioning theology. Physics despises a lucky coincidence. When early pioneers of quantum mechanics and relativity built their foundational models, they sought absolute mathematical inevitability. The highest ambition of 20th century science was to discover a single unified master equation, proving that the mass of a proton or the specific strength of gravity could not mathematically exist in any other configuration. The vast landscape of string theory completely shatters that ambition. If there are a 1 followed by 500 zeros of different ways to fold the microscopic dimensions, then our specific laws of physics are not mathematically inevitable. They are merely a random localized environmental condition within a much larger, violently expanding quantum ocean. In 1974, theoretical physicist Brandon Carter formally introduced a framework to address this precise crisis. He defined it as the anthropic principle. This concept dictates that the observed values of all cosmological quantities are not naturally equal. They possess their specific measurements simply because those exact numbers are the strict mechanical prerequisites for the biological evolution of the observer. Humanity observes a perfectly tuned cosmos simply because a perfectly tuned cosmos is strictly required to forge the heavy carbon necessary to build the human brain. This realization triggered a severe philosophical fracture within mainstream science. Many traditional researchers fiercely reject the anthropic principle, viewing it as a complete intellectual surrender. If astrophysicists explain the precise tension of the electromagnetic field by simply concluding that we would not be here to measure it otherwise, the mechanical drive to uncover the actual underlying physics permanently stalls. To empirical traditionalists, relying on biological observer bias feels less like rigorous science and dangerously close to unprovable metaphysics. Yet the sheer mathematical weight of eternal inflation makes this logic increasingly difficult to dismiss. If the boiling quantum vacuum actively guarantees the existence of every single possible physical variation across infinite parallel bubbles, then our existence is not a miracle of deliberate design. We are merely biological survivors inhabiting an extraordinarily rare statistical anomaly. We occupy a random cosmic lottery ticket that happened to roll the exact subatomic numbers required to sustain cellular division, but restricting this immense variety to isolated, separated bubbles completely ignores the absolute physical consequence of an infinite, unbroken spatial grid. A finite volume of space can only hold a finite amount of data. Human intuition views the Earth, with its specific arrangement of vast oceans, drifting continents, and complex biological organisms, as a completely singular occurrence. But if the physical vacuum of our universe stretches infinitely in all directions, uniqueness becomes a mathematical impossibility. In the year 2003, theoretical cosmologist Max Tegmark formally categorized the distinct mechanical frameworks of the multiverse. He defined the most immediate, inescapable version as the Level 1 multiverse. To understand this structural architecture, consider a standard deck of 52 playing cards. There is a strictly finite number of ways those specific cards can be mechanically shuffled. If you sit at a table and shuffle that exact deck forever, you are mathematically guaranteed to eventually deal the same sequence again. The observable universe operates on this exact same combinatorial logic. The visible cosmos is simply a massive spherical volume of space illuminated by ancient light. The subatomic particles contained in that volume obey the strict rules of quantum mechanics. That imposes a hard mathematical limit on how many different ways those particles can be arranged before geometric patterns must repeat. Tegmark calculated the exact spatial distance required to exhaust every single possible subatomic arrangement. If you travel roughly 10 to the power of 10 to the power of 115 meters in a straight line through an infinite cosmos, you will exhaust every possible variation of matter. You are mathematically guaranteed to encounter an identical spherical volume of space. At that exact coordinate, the fundamental atomic structures repeat perfectly. There is another solar system, another terrestrial planet, and a physical duplicate of you sitting in the same position with the same biological memories and making the same mechanical decisions. This is not a parallel dimension or a mystical alternate reality. This exact duplicate exists in our own physical universe, separated only by an incomprehensible expanse of ordinary vacuum. This Level 1 architecture guarantees infinite copies of our exact timeline, while the Level 2 architecture, driven by the dynamics of eternal inflation, guarantees infinite variations of entirely different physical laws. Yet both of these massive cosmological frameworks assume that physical matter is the foundational building block of reality. That assumption completely fractures when you try to remove the physical universe and replace it with cold, unyielding mathematics. Humanity has fundamentally misunderstood the relationship between reality and mathematics. For centuries, the scientific establishment assumed that mathematics was simply a highly efficient biological tool, a descriptive language invented by the human brain to calculate the mechanical behavior of the physical universe. In 1998, Max Tegmark proposed a radically inverted framework, ultimately categorizing it as the Level 4 multiverse. Tegmark argued that mathematics is not a descriptive language. Mathematics is the actual physical substance of reality. To comprehend this absolute abstraction, consider the fundamental nature of a geometric cube. The cube possesses strict, unyielding mathematical properties that remain completely true whether a human mind is actively thinking about it or not. The structure exists entirely independently of our biological perception. Tegmark expands this exact logic to encompass the entire cosmos. He postulates that the physical universe is not just accurately described by mathematics. The universe literally is a massive, complex mathematical structure. The biological sensation of physical reality, the solid feel of heavy rock, the fierce heat of a burning star, the steady passage of time, is simply what it is like to exist embedded inside a self-aware mathematical structure. This framework triggers an absolute metaphysical consequence. If our specific universe is purely a mathematical structure, then strict logic demands that every single mathematical structure, completely free of internal contradiction, must also possess equal physical reality. There is no cosmic filter deciding which equations are allowed to become physical matter and which remain abstract ideas. Every coherent mathematical system actively exists as a completely independent, fully functioning physical universe. This Level 4 architecture represents the absolute limit of modern theoretical physics. It successfully accounts for every single physical possibility, every variation of quantum law, and every conceivable geometric space. Yet defining everything in existence as pure mathematics forces astrophysics into a brutal empirical corner. A theory that explains everything risks becoming a theory that proves nothing. If the multiverse is an absolute, infinite mathematical certainty, the traditional scientific method strictly demands physical proof. That demand shifts the burden from theoretical whiteboards to the freezing lenses of orbital telescopes, forcing astronomers to search the oldest light for the kinetic scar of a massive cosmic collision. Science fundamentally demands physical verification. A hypothesis that cannot be tested by an instrument or measured by a sensor is traditionally categorized as philosophy, not physics. The entire framework of the multiverse faces a severe empirical crisis. If infinite parallel realities are permanently locked behind an uncrossable void of ever-expanding space, humanity can never send a probe or a photon to verify their existence. The observable universe is strictly defined by an absolute geometric boundary. Anything beyond that visual horizon is permanently erased from our physical perception because direct observation is mechanically impossible. Skeptics frequently dismiss the multiverse as speculative mathematics. But this dismissal fundamentally misunderstands the mechanical evolution of modern theory. Astrophysicists did not deliberately invent the concept of parallel universes to sound profound or to excuse missing data. The multiverse is a mandatory mathematical byproduct of the physical laws we already know to be absolutely true. Consider the standard model of cosmic inflation. The extreme spatial expansion that perfectly equalized the background temperature of our early universe is heavily supported by decades of rigorous orbital data, Yet the exact equations that successfully prove this local inflation also strictly dictate that the high-energy vacuum generating it can never permanently shut down. You cannot mathematically accept the verified reality of our local Big Bang without simultaneously accepting the infinite ongoing generation of other cosmic bubbles. They are two inseparable mechanical halves of that very same equation. Furthermore, astrophysics does not always require direct visual confirmation to establish a physical fact. Humanity has never visually observed the microscopic architecture of an individual atom, nor have we directly illuminated the crushed singularity of a supermassive black hole. We confirm their absolute existence by meticulously measuring their kinetic and gravitational impact on the surrounding environment. Therefore, to physically prove the existence of a completely separate invisible universe, astronomers do not need to engineer a telescope capable of piercing the infinite expanding void. They simply need to examine the absolute oldest light illuminating our own cosmos and hunt for a massive thermal scar. That scar would be the kinetic bruise left by a violent macroscopic collision with an alien reality. The absolute oldest light in existence holds a physical anomaly. In the year 2004, orbital satellites mapping the cosmic microwave background, the residual thermal radiation completely saturating the vacuum since the Big Bang, detected an immense, inexplicable irregularity. As astronomers charted the microscopic temperature fluctuations across the entire observable cosmos, they discovered a colossal region in the southern hemisphere that was significantly colder than the surrounding vacuum. This thermal depression spans an incomprehensible distance. It is roughly 1.8 billion light-years across. Under the standard model of classical cosmology, a continuous region of space this massive and this devoid of thermal energy simply should not exist. Mainstream astrophysics immediately sought a localized mechanical explanation. Many researchers propose that this anomaly is simply a supervoid, a vast, relatively empty stretch of space containing remarkably few galaxies. Such a void would naturally drain kinetic energy from ancient photons passing through it. While mathematically plausible, subsequent optical surveys have struggled to confirm a void massive enough to account for the temperature drop. This lingering empirical gap creates a physical testing ground for the multiverse hypothesis to be examined. Theoretical cosmologists suggest that this massive thermal depression is not an internal structural defect, but an external kinetic bruise. During the chaotic fraction of a second when eternal inflation occurred, our specific quantum bubble expanded aggressively. Another parallel bubble may have expanded too close. The two distinct cosmic membranes physically collided. This monumental impact would have shocked the expanding plasma of our early universe. It would leave a permanent, massive thermal scar embedded in the foundational light of reality. If this highly debated hypothesis is eventually confirmed by next-generation telescopes, it completely redefines the strict boundaries of physical science. It transforms the multiverse from an abstract mathematical necessity into a verified geographic reality. Yet if the boiling quantum ocean keeps relentlessly generating and occasionally crashing these isolated universes together, astrophysics will have to confront the thermodynamic fate of the inflation process. Scientists must then ask whether this infinite generator of reality could have its own mechanical expiration date. Energy cannot be created from nothing. This fundamental law of thermodynamics governs every biological cell and burning star within our local universe. Yet the framework of eternal inflation appears to violently violate this absolute rule. If the high-energy vacuum of space is continuously stretching exponentially faster than light and dumping raw kinetic power into trillions of newly forged bubble universes, the math requires an infinite source of mechanical fuel. Human logic insists that any physical engine, regardless of its immense scale, must eventually exhaust its reserves and permanently stall. Modern cosmology resolves this severe paradox by completely redefining the actual structural cost of a universe. When theoretical physicists mathematically calculate the total thermodynamic budget of our observable cosmos, they must account for both positive and negative physical values, the physical mass of every spiral galaxy, the kinetic heat of every star, and the outward pressure of space itself all possess strict positive energy. However, the exact mathematical counterweight to this physical mass is gravity. The immense gravitational tension pulling between all physical objects acts as a massive, invisible reservoir of negative potential energy. The total net energy of our entire universe is exactly zero. This mathematical reality is absolute, because creating an entirely new bubble universe requires a net energy of zero. The boiling quantum ocean does not actually consume any fuel to forge them. The violent mechanics of eternal inflation can theoretically operate indefinitely. The rapidly stretching vacuum freely extracts infinite parallel realities from the expanding void without ever violating the strict conservation of energy. Yet while the raw structural energy might be mathematically free, the overarching physical flow of time strictly is not. The second law of thermodynamics mathematically guarantees that even an infinite, self-sustaining physical system must continuously degrade from an ordered kinetic state into complete thermodynamic chaos if the greater bulk of reality is forever locked in a relentless boiling cycle of chaotic quantum inflation. Astrophysics must directly confront a deeply isolating possibility. Our perfectly ordered, mathematically stable timeline is likely nothing more than a temporary geometric error within a much larger, completely disorganized void, forcing the scientific lens to abandon the distant geometry of space and fundamentally question the actual, immediate meaning of human biological choice. You are fundamentally defined by the physical choices you mathematically abandoned. If the equations of Hugh Everett are physically absolute, the quantum probability wave never collapses. Every time your biological brain processes a mechanical crossroad, the geometry of space violently fractures to accommodate every possible outcome. Somewhere across the incomprehensible expanse of the multiverse, an exact atomic duplicate of you is currently enduring the precise consequences of the decisions you explicitly rejected. Human intuition frequently views this infinite physical duplication as deeply paralyzing. If every single mathematical possibility is strictly guaranteed to occur within a parallel timeline, the biological sensation of free will appears completely erased. If thermodynamic failure is absolutely guaranteed in one expanding universe and kinetic success is mathematically mandated in another, the daily physical struggle of your current existence can easily feel entirely meaningless. But the absolute mechanics of quantum physics firmly reject this philosophical surrender. Hugh Everett died in 1982, completely alienated by a scientific establishment that fiercely mocked his branching mathematics. He did not live long enough to watch mainstream theoretical physics slowly embrace the undeniable mechanical logic of his fractured reality. Yet his mathematical legacy provides a stark, grounding perspective. Your specific biological consciousness is not a distributed mathematical network. It is strictly anchored to one highly specific, linear geographic trajectory through the infinite quantum bulk. You do not possess the biological hardware to physically experience the vast multiverse. You are permanently bound to the kinetic friction of this exact isolated timeline. The thermodynamic weight of your immediate actions and the physical consequences of your daily choices remain entirely absolute to the specific atomic structure you currently occupy. The staggering architecture of eternal inflation and branching quantum reality does not diminish the mathematical value of your isolated existence. It physically elevates it out of a 1 followed by 500 zeros of utterly sterile geometric combinations and across an infinite boiling ocean of violently expanding vacuum. Your specific atomic structure successfully coalesced into a conscious observer. You are a highly localized, fiercely improbable biological machine, granted the deeply brief mechanical capacity to look upward and actually comprehend the sheer scale of the chaotic void you somehow managed to survive. You are currently processing this exact sentence. Your biological brain fundamentally registers this specific fraction of a second as the absolute definitive present. You instinctively separate reality into a rigid history that is permanently closed and a future that remains entirely unwritten. But the underlying machinery of the cosmos completely rejects this biological sensation. When theoretical physicists strip away human perception and examine the absolute mathematics governing the structure of the universe, the familiar architecture of reality fractures. The patterns we take for granted collapse. The equations strictly dictate an uncomfortable truth. At the deepest subatomic level, the concept of now simply does not exist. Human intuition demands that time flows forward like a relentless kinetic river. We measure our existence by the steady mechanical degradation of our own biological cells. If you isolate the fundamental quantum particles that make up your body, you see a very different picture. Protons anchoring atoms and fast-moving electrons bonding molecules are oblivious to the passage of time. The core nuclear equations that perfectly calculate the behavior of these microscopic particles contain absolutely no mathematical arrow pointing toward the future. They possess no built-in mechanism to distinguish a past event from a future consequence. To a fundamental particle, time is not a flowing river. It is a completely static, flat geometric grid. This is not a philosophical abstraction. It is a rigorous, mathematically proven feature of the standard model of physics. The sense that time passes is a localized cognitive illusion, produced as the brain processes large amounts of thermodynamic change. The actual foundational universe is utterly blind to the direction of your existence. In the realm of fundamental mechanics, tearing an atomic structure apart and perfectly reassembling it are still mathematically identical actions. If you could reverse the kinetic trajectories of every particle in the cosmos, the equations would still hold. Physics operates on strict mathematical symmetry. Consider the orbital mechanics of our local solar system. If you recorded a visual tracking of the Earth circling the Sun and played that recording completely backward, the motion would look wrong to a biological observer. But if you hand that exactly reversed kinetic data to a classical physicist, the foundational equations still hold. The mechanical laws of motion, drafted by Sir Isaac Newton, function flawlessly in either temporal direction. A geometrically reversed orbit perfectly obeys the exact same gravitational math as a forward orbit. This profound symmetry extends directly down into the microscopic architecture of reality. In standard quantum electrodynamics, an electron traveling forward through space can spontaneously release a packet of light, mathematically categorized as a photon. If you strictly reverse the mathematical timeline of that exact event, the equation simply describes an electron actively absorbing a photon. Both mechanical actions are completely legal under the strict rules of quantum mechanics. The fundamental mathematics completely refuse to prioritize one temporal direction over the other. Theoretical physicists define this core structural property as time reversal symmetry. It strictly dictates that the foundational bedrock of the cosmos is entirely indifferent to the past or the future. Every single atomic collision, every burst of radiation, and every subatomic interaction can mechanically run backward without violating a single structural law of physics. The universe, at its most fundamental level, is functionally timeless. Yet this perfect microscopic symmetry creates a stark contradiction when we scale it up to macroscopic proportions. If each subatomic particle in your body can run backward as easily as it runs forward, physics faces a real empirical problem. Science must explain why broken things do not reassemble themselves. Science must explain what invisible mechanism makes a heavy glass shatter violently on a concrete floor, and why those exact same shards never spontaneously reassemble into a perfect cylinder. In the late 19th century, the global scientific establishment was fiercely divided over the fundamental architecture of reality. The vast majority of prominent physicists completely rejected the existence of atoms, viewing physical matter as a continuous, unbroken fluid. An Austrian physicist named Ludwig Boltzmann vehemently disagreed. He recognized that to successfully explain the macroscopic behavior of the universe, science had to accept that everything was constructed from microscopic, discrete particles. Boltzmann dedicated his career to solving a glaring mechanical flaw in the physics of heat. If you drop a heated block of solid iron into a basin of cold water, the thermal energy always bleeds outward, rapidly heating the water until the temperature strictly equalizes. Under the fundamental mathematical laws of energy conservation, it is entirely legal for the ambient heat in the water to suddenly rush back into the iron block, freezing the liquid and turning the metal red hot again. Energy is completely conserved in both scenarios, yet the backward trajectory never physically occurs. To explain why this thermal traffic strictly travels in only one direction, Boltzmann introduced a radical new framework based entirely on mathematical probability. He defined this mechanical tendency as entropy. Imagine dropping a handful of perfectly ordered coins onto the floor. The strict mathematical probability of every single coin landing on the exact same side is astronomically low. There are simply billions of more ways for the kinetic energy of the impact to scatter the coins into a completely disordered randomized pattern. Boltzmann proved that the kinetic heat inside the iron block operates on this exact same statistical logic. Heat transfers from hot to cold simply because there are infinitely more mathematical ways for the raw kinetic energy of trillions of moving atoms to spread out evenly than to remain highly concentrated in a single geometric location. By anchoring macroscopic heat flow to statistical probability, Boltzmann uncovered the physical engine behind the arrow of time. He did not foresee how controversial his rigorous mathematical proof would become, and he spent years defending the atomic theory to an academic world that refused to accept machines it could not see. A heavy glass cylinder shattering against a concrete floor is a permanent kinetic event. Human intuition assumes that a mysterious invisible force called time strictly prohibits the shattered fragments from spontaneously launching off the ground and reassembling into a perfect cylinder. But as established by the fundamental symmetries of physics, there is absolutely no mechanical law preventing this reversed action. The kinetic energy dispersed into the concrete could mathematically transfer directly back into the shards, perfectly fusing the atomic bonds. The actual barrier is not a physical law. It is sheer mathematical probability. To understand the mechanics of this probability, examine the exact atomic structure of the object. For the glass to exist in a completely unbroken state, billions of individual silicon and oxygen atoms must be locked into one highly specific, rigid geometric arrangement. There is exactly one mathematical way to maintain that perfect order. However, the moment the physical impact breaks the structural bonds, those billions of atoms are instantly freed. There are trillions upon trillions of different, completely random ways those atoms can scatter across the concrete floor. The transition from a perfectly intact glass to a shattered pile of debris is not driven by a flowing river of time. It is driven purely by statistical inevitability. The universe is completely blind. It simply shifts from a geometric state that is incredibly rare to a chaotic state that is overwhelmingly probable. This is the absolute core of the second law of thermodynamics. The forward arrow of time is the mathematical progression from highly organized structures into kinetic chaos. It follows statistical rules that make disorder overwhelmingly likely. Ludwig Boltzmann reduced the mystery of time to a statistical equation about atomic probability by proving that the macroscopic flow of reality was dictated by microscopic invisible particles. He directly challenged the rigid dogmas of the 19th century scientific elite that provoked a brutal academic backlash that broke his psychological endurance long before the physical evidence could vindicate his mathematics. Scientific progress is rarely a peaceful transition of ideas. It is frequently a brutal war of attrition. For decades, Ludwig Boltzmann fought a solitary battle to defend his statistical engine of time. The prominent physicists of the late 19th century were aggressively hostile to his atomic framework. They fundamentally refused to believe that the solid, predictable reality they could physically measure was mechanically governed by invisible, chaotic particles bouncing randomly in the microscopic dark. To the established scientific elite, matter was a continuous, unbroken fluid. They publicly mocked his probability equations as mathematical fantasies, actively dismissing his groundbreaking work as a philosophical failure entirely detached from physical reality. Boltzmann suffered from severe, exhausting cycles of depression. He grew convinced his life's work would be permanently erased from scientific history, crushed under the overwhelming weight of academic consensus. He bore the psychological strain of a man who understood the universe mathematically. He could not make the scientific community open its eyes. In September of 1906, while vacationing in Italy, Boltzmann finally surrendered to the isolation. He took his own life, completely unaware that the global scientific paradigm was already beginning to fracture. Less than a single year after his death, experiments analyzing the motion of microscopic particles suspended in liquid confirmed the existence of atoms. Those empirical results mathematically supported Boltzmann's ideas. Boltzmann was posthumously vindicated. His rigorous equation defining thermodynamic entropy proved so fundamental to the survival of modern physics that it was permanently carved directly into the heavy marble of his gravestone in Vienna. Boltzmann successfully proved that the statistical probability of invisible atoms aggressively drives the forward arrow of time. Yet while his mathematical thermodynamics perfectly explained why a shattered glass can never reassemble, a young clerk sitting in a quiet patent office in Switzerland was finalizing a completely separate set of equations, a radical geometric framework that would soon completely erase the very concept of a flowing timeline, threatening to freeze the entire cosmos into an eternal, unyielding block of solid space. Absolute time is a biological illusion. For over 2 centuries, classical physics relied completely on the mechanical foundation built by Sir Isaac Newton. He mathematically defined time as a rigid universal clock, ticking constantly in the background of reality. Under this classical framework, 1 second passing on Earth was strictly identical to 1 second passing in the deepest void of space. Time was an absolute invisible river carrying all physical matter forward at the exact same relentless speed. In 1905, Albert Einstein completely shattered this universal clock. Einstein realized that space and time are not independent mechanical systems. They are permanently welded together into a single highly flexible physical fabric known as space-time. To visualize this profound mechanical shift, stop thinking of time as a ticking metronome. You must envision time as an actual physical direction. Human biology easily perceives three spatial directions: length, width, and depth. You can freely walk forward, step sideways, or climb upward. Einstein mathematically proved that time strictly functions as the fourth geometric direction. Every single second you experience is not a moment simply vanishing. It is a physical step you are actively taking along a four-dimensional axis. Because space and time are fundamentally bonded, your kinetic movement directly manipulates your timeline. The universe dictates a strict speed limit. If you accelerate your physical body rapidly through the three dimensions of space, you mechanically divert your momentum away from the dimension of time. The faster you move through space, the slower you physically travel through time. This completely eradicates the concept of a synchronized cosmos. Every single object in the universe possesses its own completely independent timeline, dictated entirely by its specific kinetic velocity. Yet fusing time perfectly into the rigid geometry of space triggers a severe geometric consequence. If time is simply another physical direction, exactly like length or depth, then physics strictly demands that the past and the future are not fading memories or unwritten possibilities. They must physically exist in their entirety right now, permanently embedded in the cosmic grid in the exact same way that a distant physical city firmly exists, even when you are not currently standing inside it. The universe is already finished. Human biology insists that reality is actively unfolding. We deeply feel that the past is entirely gone and the future remains completely unwritten. However, by mathematically fusing time and space into a single geometric fabric, Albert Einstein inadvertently created a framework that completely paralyzes the cosmos. If time is strictly a physical dimension, like depth or length, then every single point along that specific dimensional axis must permanently exist. Theoretical physicists categorize this profound structural reality as the block universe. To comprehend this concept, imagine holding a physical reel of movie film in your hands. The fictional characters printed inside the film firmly believe they are experiencing an unfolding, unpredictable timeline, completely unaware of their future. But you holding the reel from the outside can physically observe the beginning, the middle, and the end existing completely simultaneously on the exact same strip of plastic. The four-dimensional structure of space-time operates on this exact same geometric logic. Imagine flying in a high-speed aircraft over a massive, rugged landscape. The heavy mountains miles ahead of you and the deep valleys firmly behind you both exist right now, even if you can only physically observe the narrow stretch of terrain directly beneath your immediate window. In the strict mechanics of the block universe, the violent ignition of the Big Bang, the construction of the ancient Egyptian pyramids, the exact moment you are currently experiencing, and the final thermodynamic death of the last star, all actively exist at this very second. They are permanently locked within a static, unyielding geometric crystal of space-time. The persistent feeling of time flowing forward is not a physical property of the universe. It is merely a neurological illusion, mechanically generated by a biological brain slowly processing static data frame by frame along a rigid axis. Treating the entire timeline as a flat, frozen block ignores a crucial moving factor in how events play out. Space is not a smooth, empty grid. It is aggressively populated by massive concentrations of physical matter. If time is welded to the geometry of space, astrophysics must calculate what happens to the biological experience of time as immense gravitational weight begins to crush that geometry. The local clock is dragged toward a mechanical standstill. Gravity physically distorts the passage of time. When Einstein expanded his geometric framework into general relativity, he showed that massive objects don't just pull on others, they actively warp space-time itself. Because space and time are permanently woven together, bending the physical space around a heavy planet inherently stretches the time passing through it. The closer a body is to a massive gravitational center, the deeper it sinks into that geometric depression. Its local clock ticks more slowly. This structural warping is not an abstract mathematical theory. Engineers measure it and compensate for it in modern aerospace systems. Consider the orbital network of the Global Positioning System. This constellation of navigation satellites constantly orbits roughly 20,000 kilometers above the surface of the Earth. At that extreme altitude, the mechanical tension of earthly gravity is significantly weaker than it is down on the concrete surface. Because the orbital satellites experience less gravitational drag on their local space-time, their onboard atomic clocks physically run faster than perfectly identical atomic clocks resting on the ground. The kinetic discrepancy is absolute. The satellite clocks tick precisely 38 microseconds faster every single day. While that fraction of a second sounds entirely negligible to a biological brain, it is geometrically massive. If software engineers fail to upload corrections to synchronize the orbital clocks with surface clocks, the global navigation grid would fail in about 2 minutes. Navigational errors would then grow by 10 kilometers every single day. Humanity actively calculates the relativistic warping of time every time a commercial vehicle maps a route. The physical stretching of time is a verified everyday reality. Yet the gravitational distortion generated by a standard rocky planet is mathematically microscopic. To truly observe the mechanical limits of time dilation, astrophysics must abandon the gentle curvature of Earth and calculate exactly what happens to the biological clock of an observer plunging directly toward the absolute, crushing geometry of a collapsed star. Time completely stops at the edge. When a massive star mechanically collapses under its own structural weight, it punches a severe geometric depression directly into the fabric of space-time. The absolute boundary of this profound gravitational well is mathematically defined as the event horizon. To comprehend the maximum physical limit of time dilation, you must analyze the kinetic data of a physical object plunging directly toward this unyielding boundary from the strict perspective of a distant observer. Imagine launching a titanium probe with a visible atomic clock toward the collapsed star. You remain safely anchored in a distant orbital vessel. As the probe accelerates into the steep gravitational gradient, space-time stretching around it slows its onboard clock. To your distant frame, the clock ticks progressively more slowly. The mechanical laws of relativity dictate a profound optical paradox. You do not visually observe the probe violently crossing the threshold. As the falling machine approaches the exact mathematical boundary of the event horizon, the immense gravity fundamentally stretches the photons bouncing off its titanium hull. The visual light drastically shifts into the deep infrared spectrum, and the kinetic motion of the probe exponentially decelerates. From your distant frame of reference, the gravitational warping of time becomes so absolute that the mechanical ticking of the falling clock completely flatlines. It never actually enters the dark void in your visual field. It simply hovers at the exact physical edge, fading into complete optical darkness as the visual information is stretched entirely into infinity. The external universe perceives the fallen object as geometrically paralyzed on the two-dimensional surface of the horizon forever. Yet this absolute freeze only strictly applies to the distant observer. If you were physically strapped inside that falling probe, your biological perception of time would remain completely uninterrupted. Your local clock would tick normally as you pass through the boundary and vanish from the external universe. That forces astrophysics to confront a major thermodynamic contradiction. If the physical matter entering the geometric void actively carries its own entropy with it, science must rigorously explain exactly how the early universe managed its thermodynamic equations. If gravity constantly pulls matter together to increase chaos, cosmologists must look backward to the absolute origin of time and determine exactly why the primordial Big Bang possessed an impossibly perfect, mathematically pristine state of low entropy to begin with. You witness the structural decay of reality every single day. Human biology instinctively understands that hot coffee always cools, metal machinery eventually rusts, and complex cellular structures inevitably fail. This daily observation is rigidly backed by thermodynamics, which mathematically dictates that the universe is strictly marching toward maximum kinetic chaos. But this unyielding forward trajectory immediately triggers a severe mechanical paradox. If reality is constantly falling apart, then tracing the timeline in absolute reverse strictly demands that the absolute beginning of the cosmos was perfectly, inexplicably ordered. The mainstream scientific model defines the Big Bang as a violently expansive, incredibly hot event. Human instinct assumes this primordial furnace was an entirely chaotic explosion. Physics firmly rejects that biological assumption. To comprehend this paradox, you must rigorously analyze the mechanical role of gravity. In a standard terrestrial laboratory, a completely smooth, evenly distributed cloud of gas is categorized as a high entropy state because the atoms are randomly scattered. But on a macroscopic cosmic scale, gravity radically inverts this mathematical logic. Gravity relentlessly seeks to crush physical matter together into dense black holes. Therefore, a perfectly smooth, evenly distributed ocean of primordial plasma is actually a state of extreme gravitational order. It possesses incredibly low entropy, strictly acting as a tightly wound mechanical spring holding immense potential energy, actively waiting for gravity to pull the trigger and compress the matter into burning stars and heavy galaxies. Astrophysics confirms that the infant universe was entirely smooth. The foundational plasma was distributed with absolute geometric perfection. This hyper-organized starting position is mechanically defined as the past hypothesis. The strict forward arrow of time that you biologically experience right now only physically exists because the absolute origin of the cosmos possessed almost zero thermodynamic chaos. Time actively flows forward simply because the early universe left the system vast thermodynamic room to mechanically decay. Yet the standard model of quantum mechanics completely fails to explain exactly how or why the cosmos was born in this mathematically pristine condition. The structural origin of time remains an open question. Theoretical physicists must rely on a statistical probability so incomprehensibly massive that no feasible mathematical notation can contain it. Writing out its raw digits would require more atomic material than exists in the entire observable universe. Reality is a statistical anomaly. In the late 20th century, theoretical physicist Sir Roger Penrose attempted to calculate the probability that the Big Bang would naturally produce the highly ordered, low-entropy state required for our universe. He rigorously mapped out each possible arrangement of the universe's fundamental energy during that precise fraction of a second in early cosmic genesis. The resulting number was far beyond ordinary human comprehension. Penrose discovered that the overwhelming majority of these possible starting conditions do not organically produce a smooth, expansive ocean of primordial plasma. They lead instead to a sterile state where matter collapses under extreme gravity into a web of tiny, localized black holes. He showed mathematically that the absolute probability of the initial cosmic energy randomly landing in the exact, perfectly smooth geometric configuration needed to sustain a flowing timeline is 1 in 10 to the power of 10 to the power of 123. To properly visualize the sheer mechanical magnitude of this improbability, consider the finite limits of physical matter if a theoretical engine attempted to physically write this number by placing a single zero on every subatomic particle in the observable universe. It would run out of raw atomic material long before finishing. There simply aren't enough particles to display the entire string. This figure demonstrates that the universe's foundational starting point was deeply and extraordinarily improbable. The entire forward arrow of time, the mechanical reason a shattered glass cannot spontaneously reassemble, and a biological cell must eventually decay, depends on an initial cosmic setup so rare that classical cosmology cannot explain it. The standard model of physics contains absolutely no structural mechanism defining exactly what forced the chaotic primordial vacuum to yield such a geometrically pristine starting line. While astrophysicists desperately search the macroscopic boundaries of the cosmos for the exact origin of this perfect gravitational order, quantum physicists are actively hunting for the engine of time in the completely opposite direction. To understand exactly how a fluid, unpredictable future is permanently locked into a rigid, unchangeable history, science must plunge directly back into the microscopic realm, rigorously analyzing the exact mechanical moment when a fragile quantum probability wave violently crashes against the heavy friction of the macroscopic environment. The boundary between the microscopic quantum world and macroscopic reality is strictly governed by friction. In absolute isolation, a subatomic particle does not exist in a single defined physical location. It operates purely as a mathematical wave of probability, actively existing in multiple geometric states simultaneously. As long as this fragile probability wave remains completely shielded from external interference, it strictly obeys perfect temporal symmetry. The foundational quantum equation can run flawlessly forward or backward without violating a single structural law. But the observable universe is an aggressively crowded environment. The exact moment this delicate probability wave interacts with the dense chaotic matter of macroscopic reality, whether it is physically struck by a stray photon of light or deliberately measured by a heavy laboratory sensor, the mathematical wave violently collapses. Theoretical physicists formally classify this mechanical transition as quantum decoherence. To physically comprehend this structural collapse, envision a heavy metallic coin spinning rapidly on a perfectly smooth table. While actively spinning in absolute isolation, the geometric state of the coin is a complete blur. It is neither strictly heads nor strictly tails. However, the exact fraction of a second, a single heavy grain of sand physically strikes the spinning edge. The kinetic interference actively forces the metal to crash flat onto the solid surface, permanently locking it into one defined physical state. Quantum decoherence mechanically functions as that exact kinetic impact. When the microscopic wave actively brushes against the heavy macroscopic environment, the delicate internal quantum information violently leaks outward into the surrounding thermodynamic chaos. Because this complex kinetic data rapidly disperses into the vast thermal background of the cosmos, it strictly becomes mathematically impossible to gather that exact physical information back together to reconstruct the original probability wave. This purely one-way leakage of quantum data permanently anchors the forward arrow of time directly into the foundational fabric of reality. The timeline strictly marches forward because every single fraction of a second, trillions of fragile quantum probabilities constantly crash against the heavy physical environment, permanently locking a fluid, unwritten future into a rigid, unchangeable history Yet, as the relentless engine of entropy actively exhausts the physical matter of the cosmos over trillions of years, the heavy macroscopic environment must eventually evaporate. The geometric framework of reality will slowly expand into an entirely cold, sterile vacuum. The universe is slowly bleeding out. To extract mechanical work from any physical system, thermodynamics strictly demands a profound difference in temperature. Consider a classic industrial steam engine. The heavy steel pistons only generate kinetic power because there is a severe thermal gradient between the boiling hot water inside the boiler and the freezing air outside. If the internal water and the outside environment ever equalize to the exact same temperature, the mechanical engine permanently stalls. The flow of energy completely stops. The observable universe mechanically functions as an incomprehensibly massive steam engine. The heavy fusion cores of burning stars act as the blazing boilers, constantly dumping raw kinetic heat into the freezing vacuum of deep space. This exact thermal imbalance physically fuels the entire forward arrow of time. It actively drives the structural rotation of heavy galaxies, the violent collapse of primordial gas clouds, and the slow biological evolution of cellular structures on a rocky planet. But the mathematical equations of entropy strictly dictate that this cosmic thermal gradient is entirely finite. Astrophysicists can geometrically calculate the extreme trajectory of this thermodynamic depreciation. Fast forward roughly 100 trillion years into the deep future, the final active star will permanently exhaust its internal nuclear fuel, slowly fading into a dark frozen cinder. The entire cosmos will plunge into absolute optical darkness. Fast forward an additional one followed by 100 zeros of years. The massive dormant black holes left to wander the lightless void will slowly evaporate through microscopic quantum radiation. They will eventually dissolve entirely, leaving behind a completely scattered, freezing mist of isolated subatomic particles. At this exact mathematical coordinate, the expanding universe reaches absolute maximum entropy. Every single cubic meter of deep space equalizes to the exact same freezing temperature. It rests merely a microscopic fraction of a degree above absolute zero. There is absolutely no concentrated thermal energy left to trigger a chemical reaction, form an atomic bond, or transfer physical data. The physical cosmos becomes perfectly geometrically frozen. Yet this absolute mechanical death forces theoretical physics to confront a profoundly disorienting paradox. It calls into question the foundational architecture of reality. If the forward flow of time is strictly dependent on the thermodynamic decay and kinetic movement of physical matter, then an entirely static, perfectly frozen universe must trigger the geometric death of time. Time would no longer register a sequence of events. Time is not an independent physical structure. It is purely a mathematical measurement of kinetic change. If every single subatomic particle in the cosmos eventually reaches the exact same freezing temperature and all thermodynamic movement permanently ceases, the universe loses the mechanical capacity to register a sequence of events. Without physical change, there is no measurable difference between a single passing second and 1 trillion empty years. When the massive engine of entropy finally forces the universe into a perfectly static frozen geometry, time does not merely slow down. Time mathematically ceases to exist. The profound realization of this absolute cosmic silence forces a radical shift in how humanity must view the current passing moment. You do not reside in a permanent, unyielding reality. You actively occupy an incredibly narrow, highly unstable thermodynamic window. You are currently existing in the exact brief cosmological epoch where the raw energy of the primordial Big Bang is still aggressively cascading downward into absolute kinetic chaos. This specific state of thermodynamic imbalance is the mechanical requirement that allows cellular biology, chemical reactions, and conscious perception. The rigid mechanics of the block universe dictate that the timeline is already geometrically finished. Entropy strictly guarantees that the deep future is entirely dark. Yet this absolute mathematical certainty physically elevates the exact moment you are currently experiencing. The forward arrow of time is not a slow mechanical march toward a dark void. It is the exceedingly rare kinetic privilege of actual existence. Consider the fragile biological friction of your immediate reality. Think of the meticulous, deliberate shape of a windswept yellow apricot tree against the elements, or the heavy warmth of a young son resting on his mother's knee. To a traditional astrophysicist, these are merely temporary, highly localized states of low entropy. But in the grand, freezing architecture of an infinite cosmos, these fleeting physical actions represent the absolute pinnacle of reality. They are the rare, geometrically perfect fractions of a second when a fundamentally blind mechanical universe briefly concentrated enough localized heat to support life, allowing matter to record events and for a human choice to have real physical effect.